I'm Brandon. Well, uh, is Pluto gonna be your favorite former planet, or is that gonna be like Ceres, your favorite former planet, or even Alderaan? Yeah. Well, we haven't started the game yet. All right. Okay, fair enough. All right, but so I think we have at least one person watching, which is exciting. So drunken rambling. Ooh, delightful. Ooh, who's that named after? Clyde. All right, and I am drinking Tholin. Tholin is some gunk we're going to talk about later on in the episode, but it's a very basic ingredient. So it's just some whiskey with a spritz of orange in there. Very basic. Yeah, basic. Well, giving Lily is some of the glowing, technically. There. Oh, clever. Yep. Yep. We okay. I would say if we do a Lord of the Rings reference, but we would die. We would very die. Yeah. Yeah. What year is it? Oh, indeed. Yeah. Uh, La Pasha. Yes, thank you, Ms. Davison. Apparently, Twitch can only hear me, so we're just gonna go with it for a little bit. Well, you didn't turn the audio on?
Didn't. Okay.
Now we're good.
Now we should be in business. So,
So hi Chuck. Hi Chuck. I know you're listening.
Hey. Hey.
Quick recap: drink if a dog barks, and drink if we make a Star Wars reference. And here we go. And these are astronomy events of the week.
If you still can't hear us, let us know, and then I'll.
Yep. Chat. Put a chat in. All right. Anyway, so by the way, interestingly enough, that patent was declined. Yep. So I guess they did not see the value in it.
See the value in a magnifying glass.
Yeah.
Which is weird because it was military use at first. You didn't really care about looking up in the sky. It was how far over the horizon can you see the enemy coming.
Yeah, of course it was military first.
All right, so that was 1608. Go forward a little bit to 1920, October 1st, 1920. Nuclear fusion in stars, the sun and stars was figured out. You have heard this name before, Eddington.
Arthur
Eddington.
Yeah, what a good English name. Drink.
Right off the bat.
Seriously?
Knew it. I knew that was gonna happen.
Hey.
I bet Darren's here.
I really hope not. You know what I forgot to do? I forgot to close the curtains downstairs to make it dark.
Well, that's what the break is for.
Yeah.
Anyway, so Eddington actually proposed it. He thought that nuclear fusion would power the sun and stars, and in particular hydrogen into helium, but he also thought that heavier elements could come of it as well. Hans Bethe actually worked out the process, won a Nobel Prize for it. This is also in the 1920s, and he literally, at least according to legend, physics legend, looked at the periodic table and worked out the process. It's called a proton chain, and there's actually two processes stars can use to go from hydrogen to helium. So for nuclear fusion, stars like our sun will use that proton chain. The higher mass stars will actually use what's called the CNO cycle. And so, but proton chain is the main one.
And Proton Chain is also the name of my debut album.
Hey!
I'll be ready for that when that drops.
Sounds like it'd be like one of those wedding dances, you know? All right, everybody, it's time for the proton chain!
And you gotta be careful because it's hot.
Watch out. We're gonna drop it like it's hot.
Because it's nuclear fusion. Anyway.
Go forward about 12 years. And Cepheid variables found in the Andromeda galaxy. The great thing about Cepheid variables, they're pulsating stars, but the rate at which they pulsate is tied to how bright they are, their luminosity. So they're what we call standard candles, so you can use them to figure out how far away something is. So if you find a Cepheid variable inside of, say, another galaxy, you can figure out how far away that galaxy is. Go ahead. You were going to say something.
No, continue. I was just going to ask a ridiculous question.
Okay, so it was Edwin Hubble who was the first to spot it. And he spotted it in the Andromeda galaxy using the 100-inch telescope, Mount Wilson Observatory.
And I always giggle at its name for no apparent reason. It's called the Hooker.
Oh, the
telescope. The Hooker telescope. Yeah, it just makes me smile. I giggle like a 12-year-old.
Do you have to pay to use it? You pay for use?
Especially when it's erect up.
Oh man, that'd be such a great peep show. Am I right?
Oh man. Well, I was gonna ask if the Cepheid, if they're called Cepheid variables, if that has anything to do with the constellation of Cepheus.
I don't know.
Oh, okay.
Yes, it does. It does. That's where the first one was discovered.
That discovered in the
that makes
of
sense.
Cepheus. So Cepheid variables.
Yeah, so that was where the first one was discovered. So we'll go forward in time. a little bit. Unfortunately, my notes are kind of all over the place.
Well, first of all, you have too many notes. There's too many notes. There's too many things.
Yeah, but there was so
Yeah,
much
limit
stuff
it
that
down.
happened.
There was, but also we have in big bold letters. Pick a few to talk about, and we're just gonna cruise through all of them and go in depth here because there's some really cool ones coming up too.
Yeah, pick a few, but then who put in the comment? Well, I liked them all.
That was me.
All right, so fast forward a few years. The first estimate of the Milky Way's age, October 1st, 1957. This makes me laugh a little bit because the age was between 6.6 and 18 billion years.
That's a pretty
That's a massive,
wide gap.
massive range.
I mean, they're within that. It's within that. So I guess they were correct.
But you say first estimate? What do you mean by first estimate? Because we were trying to estimate that age for hundreds of years before.
Right. So there were some astronomers, Margaret and Jeffrey Burbage, which sounds like straight out of Harry Potter. William Fowler and Fred Hoyle put out a paper. Yeah, so paper of stellar physics that outlined and analyzed several key processes responsible for the synthesis of elements in the nature and their relative abundance.
That's one of my favorite papers is Synthesis of Elements of Stars. What a good paper.
Yeah, and they basically used that to come up with the age of the Milky Way. It's called the B2FH paper.
Nice. That's great naming.
Well, it's named for the Burbages, so two B's. B2.
Oh, and Fred Hoyle.
Yep.
It's like H2O, two hydrogens and an oxygen.
Yeah.
F for Fowler and H for Fred Hoyle.
Yeah. And I was also thinking this may have been the first actual estimate of the Milky Way because a couple of decades before this, you had a great debate in astronomy whether or not the Milky Way is the entire galaxy or is the entire universe, rather.
Right.
And those other dots out there are just nothing else. So I guess this is the first time we've confirmed that, yes, the Milky Way is one galaxy amongst a sea of galaxies. So let's figure out how old ours is.
Well, no, I mean...
No? I was so close.
Well, you were, but I mean, with Hubble and the Cepheid variables, he was able to figure out the Andromeda galaxy is not in our galaxy.
We'll talk about that. We'll talk about that later on.
Yeah, and so this is the first to actually put an age on the Milky Way itself. So, 1957, big year. A couple of days later, the launch of Sputnik occurred.
Sputnik.
What does Sputnik mean again? Traveler?
Sure.
Thank you for looking right at me. It's something like fellow traveler, peaceful traveler, something like that.
Something nice and sweet.
And not at all menacing.
And it freaked people out.
Yeah. So that was the beginning of the space race.
Except for the Truman administration, because they kind of knew it was coming and didn't get what the big deal was up until Sputnik 2, when Eisenhower then fired his science advisor. But that's a whole nother podcast.
Yeah.
A year later, NASA was founded.
NASA!
Hey, NASA!
October 1st, 1958.
Take that, NACA.
All right, and so 1959, October 7th, 1959, the first image of the far side of the moon happened. Ooh. And this is a cool-ass story. All right, so it was a Soviet spacecraft. Uh-huh. It was Luna 3. And Luna 3 was the first spacecraft to actually get a gravitational assist. It needed that to return to Earth, as we'll find out here in a moment.
A little slingshot action.
So what it did was it clearly went. It was also the first spacecraft to be stabilized. That it could be stabilized in 3 different directions, which is important if you want to take a picture, because you want to be stable on that planet,
at your object.
on that object. So it went to the far side of the moon, took the picture. This was film. It took a film picture, a picture on film.
It was film in space?
Film in space. And
film.
it actually has...
Best dark room.
Luna 3 had its own dark room. And so it took the pictures. It was like 30 pictures or something. I don't remember. It took the pictures and then moved the film into its processing dark room, its lab, developed the pictures, and then using some CRT technology, shine a light through that actual film, and was able to make a digital picture of it. But originally, it was actually on film. So how do you get that picture to Earth? At the time, the transmitter wasn't strong enough, so it had to use a gravitational assist from the moon to go to the Earth and to beam those pictures back down to the Earth. And
wow.
And it obviously did it, but at first they weren't getting the signal from it as it approached Earth because it was too weak. But then eventually they were able, obviously, to get some pictures and download those pictures and showed it.
In 1959.
This is an amazing
just
technology.
An amazing story.
They took a photo on film and then beamed it back to Earth digitally.
Right. Right.
Beamed it
Wow.
back to...
Also, I would like to point out that if you might have heard, Mike called it the first image of the far side of the moon. It's not called the dark side. It does see sunlight back there, people.
I'm
It is
really
not
glad
Pink
I didn't call
Floyd.
it the dark side of
It's
the
the
moon.
near side and far side. Remember, astronomers are obvious when they're naming shit. Near side, far side.
Damn you, Pink Floyd, but amazing
Pink
music.
Floyd's awesome. So.
Well, even
Yeah.
at the end of the album, they go, there really is no dark side of the moon. Like, you guys couldn't say that, like, in the beginning?
You know, like a little, like an asterisk on the cover of the
Very small
album,
print.
just like
Right.
it's
In the
small
liner
print.
notes.
There is no dark side of the moon. It is the far side.
Yeah, but when the Soviets got the picture back, it was completely different from what anybody was expecting for the moon. When you look at the moon,
Right.
near side, filled with craters, beautiful mare.
The dark spots on the moon.
Mare.
There's
That's Amare.
Hey.
there is no mare. There is no mare on the far side of the moon.
Right.
So the far side of the moon is nothing but craters.
Heavily cratered.
And
We
so-
need to have a podcast just about the moon, because I
we
want to
do.
go off on this.
Let's not get into it. Google Moon Mare. We will get into it at a later date because we could spend the rest of the show talking about.
We could.
We have another moon-sized object to talk about.
We do. A
But
little bit smaller
I
than the
do
moon.
just want to say one thing.
Okay,
no,
say your one thing, Mike.
No, I will say that one of the big mysteries of the moon has to do with why it's all craters on the far side, and it's the crust of the moon on the far side is thicker than the crust on the near side. So the question is why? That's a really big mystery right now.
Is it? I thought
is-
it had to do with the Earth's gravity and it.
Well, that was one of the theories, which is really cool.
So, but we don't know for sure.
So it's a hypothesis.
Right, so really quick, because the moon is tidally locked to the Earth, only one side faces the Earth. The theory goes is that the Earth's gravity over these eons has been stretching out slowly the crust of the moon, letting it kind of become thinner. So when asteroids hit it, it's more likely to break open, lava spew out, and get the Mars, the seas.
Yeah, I thought that was pretty much like set in stone that was a thing that happened, but I guess not. We'll discuss that later on in a future
Yes, we will.
episode.
Hey.
But for now,
Couple more things.
never mind.
For now, what?
I keep trying to make these segues into our main topic of the show.
Well-
and every time I'm foiled.
Why did you pull my? Don't do that.
Oh, I keep thinking it's getting caught in your iPad.
No, it's
Okay.
fine. No, there are two more.
Marriage.
There's this one, and then I have one more story.
All right.
These are recent stories from
Okay.
last week.
Okay.
So,
Now to present times.
yeah, now in the present time, exactly. Giant exoplanet found around a tiny star that should not even exist. So, basically, there is a very small red dwarf star that has a planet going around it, possibly two planets, but we know one for sure, which is about half the size of Jupiter, mass-wise. So its mass is half.
The star or the planet?
The star itself is about 12% the mass of the sun, so
Okay.
it's really small.
Okay.
And then the planet itself, which takes about 7 months to go around on the star,
Ooh, that's-
is half the mass of Jupiter.
Oh, wow. Okay.
So it's pretty big. And so the prevailing thought is that when these really small stars form, they take up most of the gas and dust, and you shouldn't have big gas giant planets that are forming.
Mm-hmm.
So that's why the astronomers are saying it shouldn't exist. Well, clearly it fucking exists. So
it's an illusion.
Yeah.
It's a hologram by the U.S. military.
Yeah. So that's going to kind of push our thoughts on how planets form around other stars.
Mm-hmm.
The other news that came down this week was the Spitzer telescope. The Spitzer telescope is one of the great observatories which does infrared imagery. So when we think of big telescopes, we always think of Hubble.
Mm-hmm.
That's one of them, one of the great observatories. It's visible light. It also does some light that we can't see, but Spitzer is the main infrared one. Took a picture of a big cloud of dust and gas in the constellation of Aquila, the Eagle, and this big cloud of dust and gas has these really big bubbles in it where these newly formed baby stars with their solar wind have blown out these big bubbles surrounding them.
Little baby stars being born.
Pretty much.
It's a stellar
little
nursery.
Yeah.
Proplets.
And so that's the news.
I've always called it Aquila rather than Aquila. It's like Aquila the Hun.
And I would call it
Aquila.
like Aquila. I don't know how to pronounce it.
I think we all make up our own pronunciations with the constellations. We don't know actually how to say it.
Yeah, that's
It's
true.
an eagle. But if you, at least with the planetarium system that we use,
Oh, it did not look like
it
eagle.
looks like a stingray.
It
Yeah.
looked real weird.
Yeah.
The great stingray in the sky.
All right.
All
so
right.
now we've covered astronomy events of the week and past 100 years.
But wait, there's more.
No! There's no more astronomy events. Now we're going to get to the topic of the show, which is Pluto!
Pluto!
I got one more thing.
No.
Oh, God damn it, Mike.
I'll divorce you right here and now.
No, you won't. No, you won't.
No, it's too much paperwork. So, Pluto, a history. Let's talk about Pluto, Brandon. Where'd it come from? What's it doing? What's going on?
Where did it come from? Where did it go? What's it up to?
Cotton Eye Joe.
Thank you. So I guess we should first of all just ask the question right away before we get into Pluto. Liz, is Pluto awesome? Is Pluto...
I was drinking,
Come on,
but
come
it's
on.
the most awesome.
Is it a planet?
No.
Yes or no? Mike,
No.
No.
is it awesome?
Oh, without a doubt.
Come on,
it's awesome.
we're doing this. Okay, it's awesome. But a planet?
No.
All right, so this is what we're getting into later on. So
Wait a minute. Brandon, is Pluto awesome?
Pluto is super awesome.
Is it a planet?
It is a type of planet.
Oh.
Let's do this.
Jesus.
All right.
Oh my gosh.
All right, I see what you did there.
Yeah, I set y'all up. Haha. But yeah, a history of Pluto. We're not going to go back 4.5 billion years and talk about the evolution of the solar system, because that's going to take 4.5 billion years with us. So instead,
Yeah.
we're going to talk about the acknowledgement of Pluto in our societal knowledge. So we're going to start off in, I have the wrong notes up, but we're going to start off in 1849. This is when, I believe, a Frenchman, Urbain Le Verrier, because it sounds French. How do you say it, Mike? How do you say it? Correct me.
Urban La Verreia.
Urbain
Le
Le Verrier.
Verreia.
Verreia.
That's Italian, Liz.
Well,
You have the Italian
you know what?
fingers
They're
up
the
right
same
now.
thing. I know. It's the same with French. But it's like, how do you pronounce Perrier? Verrier. It's Verrier. Urban Le Verrier. I did it.
Yeah.
Urbain
I
Le
am
Verrier.
French.
By the way,
There you
French
go.
words may end in a consonant, but they aren't. That sound is not produced.
A. It ends in an A. Every French word ends in an
Yeah.
A. Urban Le Verrier.
But yes, Mr. Frenchman Urban.
Le
He,
Verrier.
in 1840, discovered Neptune not with a telescope, but with math and physics and witchcraft. He was able to
Witchcraft?
deduce where this planet...
There was
he
no
was able to
witchcraft.
deduce...
Don't do that. Don't
No,
do that.
there's no witchcraft. All right.
Math is kind of like witchcraft. No one knows how it really works. It just does.
But we do.
You don't know.
It's like a tide.
You
They
just
just
put a
work.
bunch of squiggly lines.
You don't know how it works. There's a
squiggly
difference.
lines and weird Greek letters.
Oh,
It's true.
okay. Continue, Brandon.
But Urban, I'm going to just call him Urban here now. Urban knew math. No, not Carl. He's my boy. But Urban here. He knew math and physics, and so he was able to deduce where a planet would be just based off the orbit of Uranus. And so in 1842, he said, this is where planet's going to be. Somebody go find it. And indeed they did. So he discovered Neptune that way with just math and physics. Well, he was looking at Neptune's orbit and realized something's not quite right. It looks as if something is tugging. There's some kind of gravity going on. So maybe there's another planet beyond Neptune that's tugging on this gravity, making it have this wonky orbit. So that kind of hit off the search for the potential 9th planet. It's a little iffy. We'll talk about why that was iffy later on. Now we're going to go forward a little bit to the 1900s with Percival Lowell. Percival Lowell. Oh, Liz has a face. She wants to say something.
Oh, no. I was just like, yay, Lowell. Because Lowell Observatory and Flagstaff.
Exactly. We'll get there in just a moment. But Percival Lowell was part of the Boston Lowell family. And this was an insanely wealthy, well-connected family. They are called the Boston Lowells. And one of the taglines that they had for each other, or I guess in Boston in general, it was Boston being home to the bean and the cod, where Lowells talked to only the Cabots, while Cabot spoke only to God. So you talk about a hierarchy of families there.
Were you saying cabbage or cabots?
Cabots, the family Cabots.
Oh, okay. Well, I'm not reading the notes. I'm listening to Brandon.
Maybe they're very esoteric and they believe talking to earthly things like cabbages can speak to God for them. Maybe. No, it was the Cabots, a richer family than the Lowells. Okay. But to give you an idea of these Lowell people and their connections, Percival Lowell's brother was a president of Harvard for like 30 years, and his sister married one of the Roosevelts.
Okay, so high society right here.
Yeah, it's like the Kennedys, basically. But Percival Lowell was the kind of the outcast, the crazy child, because he caught winds of this idea of canales on Mars.
Canale.
Canales, there you go. That's the right pictures. Because
in one sentence, what is that?
The canale?
Mm-hmm.
It is canals on Mars. That was the idea. That's what at least Percival Lowell thought it as, but it turns out the translation of canales doesn't actually mean canals.
All right, look it up, everybody.
Yeah, just look it up. But Percival Lowell caught wind of that and thought canals on Mars, how canals have to be made by someone. There are things living on Mars. There are Martians on Mars. Aliens. Let's go find them, folks.
Life on Mars.
So that was his first big interest in astronomy, was these canals on Mars. But also, he latched on to the Planet X idea, this planet beyond Mars that Mr. Urban talked about back 100 years ago. Well, I guess it had been like 50 years ago at this point. So those were his two big astronomy kicks. So he wanted to go find it. And of course, being insanely rich and wealthy, he had all the means in the world to do so. What I did stick a quote in here. I know we have Brandon quotes, but this is what, right? This is one of the coolest quotes I found by him.
All right, we're ready.
Just keep in mind that later on, after he passed away, he was essentially mocked for the idea of canals on Mars, and that he's kind of made into this general joke while still contributing huge amounts of science with the Lowell Observatory. So this quote goes: "Imagination is as vital to any advance in science as learning and precision are essential for starting points. Let me warn you to be aware of two opposing errors: of letting your imagination soar unbalanced by facts, but on the other hand, of shackling it so solidly that it loses all incentive to rise."
Wow.
Which is yeah, so it's, go crazy with the imagination, but let it be rooted in some facts.
Yes.
Yeah.
Which is really cool. So just thinking to the idea of these canals on Mars, there is proof to him that there are these lines, these etchings on this red planet. So there's base in some fact, but he's letting his imagination carry his scientific pursuits, which I think is just super cool. To put it eloquently, super cool.
It is neat. You need some imagination. We've discussed imagination in many episodes before.
We have a whole episode of science fiction if you want to go back and listen to Liz get blackout drunk.
Yeah. Yeah, that was rough. That was a rough go. But
I was drunk. Way drunk.
you were real drunk. Real drunk.
Yeah.
So you need imagination.
You do.
You do.
Exactly.
It's
Yeah.
like, we're not going to have teleporters in the future if we don't have imagination.
Yeah, but
Well, teleporters are death traps, number one.
Well,
Yeah.
I mean, obviously.
But just on a deeper level, I guess, more so philosophical level. I don't know the right terminology for this, but
Okay.
imagination lets you just see different views of things.
That's true.
And so, so there's this thing in physics where if you haven't produced your theory by 30 years old, you're not going to do it. And it's because the older we get, the harder we get to.
We can't imagine very well.
Yeah.
The more we fall back.
Brandon, you still have time.
I got
time.
Oh my god, I have like 10 months to get a Nobel Prize in physics when I'm
Do
60.
it for the rest
Let's do
of
this.
us.
Good luck, man. Good
I
luck.
got you. Thank you.
I would say I'd work the math for you, but I think I'll be able to do the math at this point. I can
All
do
right.
tips. That's all I can do.
Yeah.
Just tips. All right, moving on. So that was the Canals on Mars and the Search for Planet X. And of course, Percival Lowell, being insanely wealthy, he hired people to go across the country and said, "Buy me a good spot to put an observatory, to put a big old telescope up there." And that's when they came across Flagstaff, Arizona. And this was in Arizona. So this was in 1900. The population there was 1,271 people. And Flagstaff is kind of spreadish out. So I'd imagine it's not so much a population in 1900 as much of it is people happen to be in the general area at the time. Just kind of count them. Yeah, there's that many people here.
Just there.
But Flagstaff, Arizona has a really high elevation, so there's less atmosphere to deal with. It's what like 6,000 feet? It's over a mile. I know that much.
Sure. It's up there, which is
Yeah.
a good
So
place
it's
to
up
be
there.
also
Yeah, there's not much atmosphere to deal with,
colder.
and there only being 1,000 people, there's no light at night. So go ahead.
Yeah.
So that's exactly what happened. In 1896, they ordered the first telescope to be built in Lowell Observatory in Flagstaff, Arizona. And fun fact, 1896, that was just 2 years before War of the Worlds. So this was all culturally relevant at the time.
Yes. War of the Worlds.
That's when it was at first published, not the big radio broadcast in the third.
Well, yeah, because there wasn't radio in 1898.
Good book. Everybody should read it.
It's really fun. The BBC is coming out with a miniseries about it. Oh, not about it, but actually like a more real reenactment than the Tom Cruise version. So that's going to be exciting.
Oh, nice.
Yeah. Percival Lowell, however, ended up dying in 1916, kind of an early death. And for the next 10 years after that, Constance, who was Percival's wife, kind of tied up the observatory and all these lawsuits with the heritage and naming and things like that. So nothing really happened for 10 years. But the Lowell Observatory itself, besides, we'll get to Pluto in a moment, besides that, they have a number of really neat discoveries. So much so that Time magazine in 2006 named it one of the world's most 100 influential places.
Oh, nice.
Wow.
Cool, yeah.
Nice.
One of the big ones for us is it helped us, or it didn't help, it did discover the redshift of galaxies by Vesto Slipher. And that led to the fact that the universe is expanding with Hubble.
Mm-hmm. That means that the galaxies, their redshift is that we can see them moving away from us.
Yes, exactly.
The wavelengths of light is getting longer.
Mm-hmm.
But in your everyday experience, it's think of the sound of
a Doppler effect.
Yeah, the
So
ambulance or a police car is higher pitch coming towards you, lower pitch moving away.
So it's like that. The wavelengths are stretched.
Yep. So it discovered the redshift, or at least the galaxies are redshifting. It was a co-discovery of the rings of Uranus in 1977.
Nice.
It found the three largest known stars, the atmosphere of Pluto, some of the orbits of Nix and Hydra, two of the moons of Pluto, carbon dioxide ice on a couple of moons, and evidence that the atmosphere of the exoplanet contains water vapor.
Wow,
So
all that out of Lowell Observatory?
Yeah, it's been a part of some really neat things.
Jeez.
Yeah, it's,
So if
it's still an active.
They have
not on
the
top of the mountain where we go, but it's still an active observatory.
they have the Discovery telescope out there now doing some work, so it's active and really great. So if you're in Arizona, go check it out. It's neat.
Totally worth it.
Mm-hmm. So enter the next figure in our story. Liz's drink,
Yeah.
Clyde Tombaugh.
I drank them all already.
Oh, you did?
Gone.
We can. You need to refill in a moment.
So
Clyde Tombaugh. He was born in 1906, just a few years after the Wright brothers made the first flights. He was born in Illinois, and he showed some interest in astronomy as a young kid, probably because his uncle was an astronomer, so that kind of made sense.
There you go.
And so in his late teens, early 20s, he made his own telescope, which is super cool. And through his own homemade telescope, he drew pictures of Mars and the moon. And knowing about Little Observatory, he put them in mail, sent them to him, and said, "Hey, what do you think about this? Can I get some feedback? Yada, yada, yada." And Little Observatory sent the 23-year-old Clyde Tombaugh a letter back saying, "You want to work for us?"
If only it was that easy.
Right?
Like, hey, NASA, here's some drawings I made.
They're in crayon, but I think you'll like them.
I think they're fairly accurate.
Yeah. But yeah, he just emailed. He mailed. Millennial culture.
The technology they had way back then.
Mailed Observatory's drawings and got a job out of it. And another fun quote by Tombaugh is about astronomy. It goes, "Well, the work was tedious, but it was much more interesting than farming, as far as I was concerned."
Yeah,
and if you ever listen to his interviews or go read his interviews, he's very Midwestern. He's like, "Yeah, I found Pluto. It's about what we thought it would roughly be. It turns out it wasn't the planet we were looking for, but I'm very glad it happened."
Wow.
It's like, oh, this guy. I like it.
Wow.
Keel just...
Mm-hmm.
We weren't looking for it, but...
But we found it. So
we'll take it.
So he was working with the big telescopes in the Loeb Observatory, and one of the big developments in astronomy that helped him was called the blink microscope. And the blink microscope, okay, so we're going to go back here a little bit. When you're looking for new planets in observatories, you can't just stick your eye in there and go, "That's a planet right there. I can see it because it's waving at me."
Hello.
Right? Hello there.
Hey,
Especially with a planet that's beyond the orbit of Neptune. That's so far away that you're not going to see the rings like Saturn or the moons around Jupiter. It's going to be a faint point of light at a very small magnitude. It's very small brightness. So what you have to
Brandon?
Exactly. So what you have to do is take picture night after night after night and just look in the background and see if any of those points of light are moving.
Anything moves, right.
And if they do move, you have to go through the catalog of all known asteroids and objects to make sure, is this new or is this known? So imagine doing this for years. The tedium.
Before
computers. This is all by himself with his blink microscope. And this is where the blink microscope helps, because this helped determine the magnitude of stars relative to others in the background. So it kind of helped him see as they were moving through it, if anything jumped or anything moved. Check your catalog. Do we know it? Hey, it's something new. So you discovered a lot of comets and asteroids that way.
And by the way, at Lowell Observatory, they actually have where you can look at it. So you can actually see in the blink microscope.
Telescope?
Microscope. The blink microscope.
Oh, microscope.
You can actually look in one and actually you'll see Pluto jump. It's the Pluto picture.
Oh, I remember.
That's cool.
No, I remember doing that. I remember looking at that. Okay.
But they call it like the blink comparator or something. It's but the blink microscope.
All right. So now with that blink microscope.
This is the only time where if you blink, you will see it. Otherwise, if you blink,
or
you miss it.
You miss it. It's very clever.
And now, if you blink, you'll see it.
Thanks, blink microscope.
Thanks, eye technology.
All right. So, Mr. Tombaugh here, not doctor at this time, Mr. Tombaugh.
Just Mr.
Who is 24 years old discovering fucking planets.
God damn it.
Right. What have we done with our lives?
Nothing.
We made some podcasts.
This is what we're doing for one person. Hey.
We're getting drunk and talking about space. I don't know if he's still on. He hasn't messaged me in a while.
I don't know. It's okay.
That's fine. So we're going to fast forward now to January 21st, 1930. Clyde Tombaugh at the edge of this blink microscope, doing it night after night. He was surveying this one small section in the sky in the Gemini twins constellation area, but there were really severe winds. Had some bad weather. So that made the plates unusable, so they couldn't go back and look at the plates at the blink telescope and check it out. It was completely unusable. Ugh. So instead, he had to go back on the 23rd and 29th and take those photographs. And turns out that was the best decision, possibly, of his life, unless he really loves his wife and considers that better. So possibly this was the best decision of his life, because those two plates on the 23rd and 29th found a flicker of a change.
Oh,
Wow.
Something's out there.
Something's out there.
And because he had his catalog, he knew nothing would be in this part of the sky. He was able to say, Eureka, that's it. And which is super cool, because typically with discoveries, you don't get Eureka. You got, oh, that's weird. And then you go back and figure it out and see exactly what it was.
So,
but he knew that this was...
Is that his actual quote? Eureka.
No, that's it.
That's it.
It's not Eureka. The quote is, quote, that's it, unquote.
All right, I like it.
Because I am me, I do have a longer quote if you wanted to get technical as to what he thought at the time. Do we want the longer quote?
Yeah, go for it.
Longer quote by Clyde Tombaugh is right after he found this flicker of a change. A terrific thrill came over me. I switched the shutter back and forth, studying the images. For the next 45 minutes or so, I was in the most excited state of mind of my life. I had to check further to be absolutely sure. I measured its shift with a metric rule to be 3.5 millimeters. Then I replaced one of the plates with a 21st January plates. Almost instantly, I found the image. 1.2 millimeters east of the 23 January position, perfectly consistent with the shift of the 6-day interval on the Discovery pair. Now I felt 100% sure.
Nice.
Yes. And I want to say as well that your video is paused.
I know,
frozen,
we're frozen.
With you on a really excited face.
I know.
So you're just stoked about this discovery of Pluto, which is super cool.
I know. For some reason our camera went out, but
all right.
I'll figure it out.
Okay. But that was early
breaks are for.
late January. Right? Almost there. Almost out of break. That was late January. February. Oh, it's rough. Yeah. And then and March 13th, after they confirmed it multiple times, they went public. And March 13th also happened to be Percival Lowell's birthday, had he still been alive. He would have been 74. And also the anniversary of the discovery of Uranus.
Hey.
So it all came together.
I'd also like to just point out for people listening or watching, listening primarily, notice how we are all pronouncing Uranus. It is Uranus.
Good call.
And that's all I will say on that point.
Don't want to be an ass about it. Do we want to take a quick break or just keep going through the names and the voyages to Pluto? Because I know somebody needs more drinks and to figure out the camera action.
I do need a drink, so let's go ahead and let's take a quick break, and
all right.
We'll be back in a bit.
I don't think. Yep. I don't. We on? Hi. We did the Wayne's World countdown, but it didn't make sense in my head. All right. So as a quick recap, we just talked about Pluto, its discovery by Clyde Tombaugh with the help of Percival Lowell and Mr. Urban. And now we're going to talk about, really quick, the naming of Pluto, because it was a big competition. We have all these classically awesome names: Mercury, Venus, Mars, the god of war. No, I'm saying, I'm just recapping the planets because they have really cool names.
Okay, I was like, wait a minute.
So we got to make sure that this newest planet at the time has a name befitting the 9th planet in the solar system, the last planet. So overall, this competition consisted of over 1,000 names, and I tried for legitimately an hour today to find that list of names so I could try to rap them, but I couldn't. But
that's really disappointing. Why'd you tease us with that?
I'm so excited. I know. I got like 7. They range from Kronos, Zeus, Tomboy after Tombaugh, which was weird. Electricity, because that was new. Minerva, Osiris, Juno, Atlas, Persephone, Zixmal. And Zixmal because it is the last word in the dictionary.
It sounds like a prescription medicine.
What does it mean?
Zixmal.
I have no idea. But it also sounds like something from Scientology.
That's true.
It does.
The Zixmal is in your bloodstream.
Zixmal is Xenon's brother, whatever.
That could do it. I think strange cousin or something. And then Percival Lowell's.
And with that, we just got on Scientology's radar.
We've been there for years.
Yeah. They're gonna be filming us outside of our house.
Whatever.
Gonna shoot Thadons at us.
I can take them and their Thadans.
I'll go out there and film them. Fuck them.
Anyway,
so Zixmal, and then Percival Lowell's widow, Constance.
Katie's with us, by the way.
Hi, Katie. I miss you.
Remember, I gotta edit this in audio, so let's. All right.
Is that a bark?
No, they
it's
growl.
more of a growl.
Okay. All right. No drinks then.
No,
so Percival Lowell's widow, Constance, at first wanted a planet called Percival, and then she wanted it called Lowell, and then, for whatever reason, she wanted it called Constance after her.
Of course, I mean.
Of course, yeah. So there was some financial issues there because the estate was still funding the observatory and things like that. But in the end, the name came from an 11-year-old girl in England, Vanessa Burney.
Vanessa Burney. That was bad. That was a
Well,
bad English accent.
I also don't know if it's Venetia. It looks like Venetia.
Venetia?
Venetia?
I mean, did you do that in an Italian accent?
I was trying to be British, but it did not.
Okay, wait. Say Emily Watson to get in the zone.
Hello, I'm Emily Watson.
All right, now go with it.
I'm Venetia Burney. I'm Vanessa Burney.
That's acceptable.
Okay.
Okay, yeah.
And I declare this planet to be Pluto.
Hooray!
When you don't speak with your hands, it works better for you.
Unless I'm doing Italian, and then I need.
Because then you go all Italian on it.
Buca di Beppo. So Vanessa V, she talked to her uncle. Say, hey, it should be Pluto because of the god of the underworld. Things like that. Okay, so his uncle sent it in, and the rest is history. It is Pluto. And V actually did get at the time 40 pounds, which is like $450. It's like, hey, here you go, thanks. That's nice. Which to an 11-year-old is a fortune.
That's $1 million.
Yeah.
Uh-huh. I mean, can we pretend that it was named after Pluto the dog?
No, we can't because Pluto the dog was named after Pluto the planet at the time.
And besides, Disney has enough stuff.
That's true.
Yeah, fuck them.
So they have all my heroes.
That's true.
Except for one group. Star Trek.
Wow, so Pluto the dog is named after the god of the underworld. Take a moment, just sink that in.
And think about sinking it in because one of its moons is called Charon, who is the what do you want to call it? The boat driver. There's a word for this.
The boat driver.
The boat driver.
The ferryman. The ferryman.
The ferryman. Thank you. The ferryman of the underworld.
You found the pronunciation. I didn't know how it was pronounced. Sharon, Charon, Charon.
Karen.
I think you can do either one.
Yeah, but the guy who discovered Charon officially calls it Sharon. Not technically after his wife. At first he wanted to call it Oz. It would be kind of like Pluto and Oz. It's kind of cool. Or Persephone, but Persephone was already an asteroid this time. So in the dead of night, one night he woke up and just found Sharon in the dictionary somehow and saw, yeah, this makes sense. The boatman that sails across the river Hades. Cool. And that was that. He went back to bed. The quote is, I said, okay, and I staggered back to bed. That is the quote.
You gotta make sure he's staggering. He can't just be walking normally back to bed. He's gotta stagger back to bed.
Right, so now that Pluto officially has a name, we got to figure out what's going on there. So this is when the study of Pluto starts to begin, is once you know it's there, let's go look at it. So at first, in 1915, it was estimated that this planet X would have the mass of 7 Earths.
So bigger than Earth.
Massive Earth. Massive
or
planet.
More massive than Earth.
Right, because it's tugging at the gravity of Neptune. Remember?
And how can something small tug at such a giant gas giant's gravity?
Exactly.
Right. Fast forward to 1931. Well, now it's about 1 Earth mass. All right. 1948, 0.1. 1976, 0.01. 1978, 0.0015. And 2006, 0.00218. So it turns out that this massive planet that Urban was looking for, that Percival was looking for, well, Pluto wasn't it. Because the mass of 0.00218 Earth masses is not nearly enough mass to create the tug on Neptune's orbit to make it weird. So Pluto was not Planet X. They just happened to find it, and it was a happy coincidence.
Coincidence?
A coincidence. A happenstance and coincidence.
Okay.
Coincidence.
I like that. Mm-hmm. Coincidence.
So now we're going to get into kind of...
It really dropped mass quickly.
It did. Like, I would love to be on a diet, guys.
Yeah, I'd like to drop that amount of masses.
I would like to just go from
just
1915 to 1931. I'll just do that.
Yeah.
Like 0.1 mic mass? Yeah.
I could stand to lose 0.1 mic masses. Oh, man.
All right. Now, we're going to try to go through this next part quick, because we actually haven't even talked about Pluto yet.
I know. It's the meat of the sub. This has just been planetary foreplay. That's what this has been.
Planetary foreplay. I love that phrase so much.
That's the title. All right. Pluto, a planetary foreplay.
You know what? That actually is what Pluto is. It is basically planetary foreplay. Jeez.
But that was a dwarf planet, so what do you call that, Brandon? It was a kink. It was
Dwarf Planet foreplay.
Which is a kink, yeah.
Kink.
It's a very small fetish.
Oh god.
It's a planet fetish.
It's really good. We have one listener, and that's it.
Really? Yeah. Okay. All right. So
I'm sorry.
Katie.
It's gold.
we're gonna go now to the late 1980s. There's a group of grad students and postdocs and planetary scientists, and they're calling themselves the Pluto Underground.
The Pluto Underground.
Which is super cool, and they call themselves the Pluto Underground because before
that name.
it's not too late, because before this, you had the Mars Underground, the big movement to go explore Mars, and they got the job done. So now you had the Pluto Underground, a bunch of young people before probably age of 30, because that's, I guess, when you make your biggest discoveries.
Yeah, once you hit 30, you're done with your life.
Game over. Yeah, I got a few months to live. So the Pluto Underground decided, let's go to Pluto, let's figure this out. But the issue was they had to arrive before 2020, because Pluto has a really strange orbit. It's not on the same plane as the rest of the solar system, so it's not like flat on the table. It's tilted. And because it's tilted, the orbital arc acts in such a way where a lot of the surface, like Alaska in the winter, can go to perpetual darkness for like 100 years, Earth time. So number one, you had to get there because the orbital arc is going to plunge Pluto into eternal darkness. Number two, Pluto's atmosphere, which we knew it had at the time, was going to freeze after 2020. Mm-hmm. And finally, the Jupiter gravity assist. So when you have a spacecraft, you get it in Jupiter's gravity well and fling it around the planet to make it go faster.
Slingshot.
Slingshot. Yeah, the orbital dynamics wouldn't work after that. So it absolutely had to be there before 2020, which meant launching it like 10 years beforehand, because Pluto is really far away. So that leads us to the first real attempt to get to Pluto, called Pluto 350. This was 1990. The idea here, you have a look on your face.
Why 350?
That's a good question, Liz. So it's called Pluto 350 because that was the weight of the spacecraft, 350 kilograms.
Wow. Okay.
So can we? All right.
And that was chosen because it was half the weight of Voyager. Because just
Nobody
2 years
knows what Voyager weighs.
I like how Voyager gets the name
700
Voyager,
kilograms.
And Pluto 350.
Right. But Voyager had just passed Neptune, 2 years ago at this time? 1988, I think it passed Neptune. Yeah, so Voyager was still very much in the conscious mind of astronomers at the time. So Pluto 350 was going to the job of Voyagers and go see this last planet. But of course, things went wrong, and it never actually occurred. Fast forward to 1992, you had Pluto Fast Flyby, and this is JPL's attempt. So JPL, yeah, I know they're very imaginative at the time. Pluto Fast Flyby. It's gonna go fly Pluto really fast. So this is JPL's attempt. I'm trying to go fast to get this part through. JPL comes in, and they really didn't know about Pluto 350, so they kind of made their own thing. And the idea here was to take essentially these CubeSats, little tiny satellites that weighed 35 kilograms, and
Pluto 35.
send them. Yeah, Pluto 35, and send them really fast to Pluto. And the idea here was that it would cost less, the schedule would be much shorter because they would lie there much smaller. But then they had the issue of stacking all this new technology on there. So over time, the technology just grew schedule and cost, and it's no longer 35 kilograms. It's like 700 kilograms, and it costs $2.3 billion, which is an issue.
Wow.
Well, that was with the launch and everything like that. But also, back before it was billions of dollars, the NASA administrator, I think it was Dan Golden at the time, he said, you had to launch this mission under $400 million, and that includes launch vehicles. And launch vehicle for missions are expensive, like $400 million. So that in itself is the cost of a launch. So Alan Stern, who's a name we're going to bring up quite a bit here, I imagine. Alan Stern kind of went rogue. He jumped on the plane to Moscow without not NASA's consent and talked to the Russian Space Agency and goes, Russia, I know y'all just collapsed the Soviet Union, but I got this really cool plan. I want to get to Pluto, but we want to use a Russian rocket. That way we can work together to get to Pluto and a reduced cost. And so the Russians lean back and go, yeah. Which means no. Which means no, folks. I am cultured.
Or does it mean not yet? Not yet.
Well,
Condensed.
true.
Yet.
It kind of does not yet because they had a condition. The condition was they would attach an atmospheric probe to this Pluto flyby. So as this spacecraft is flying by Pluto, they would detach and go through the atmosphere of Pluto. So Russia would kind of get more credit. But hey, we're at Pluto. Let's go do it.
That'd be pretty cool.
It would be super cool.
That would have been awesome.
So he kind of has his handshake deal. He comes back to NASA. NASA goes, okay, you did a good job. Way not to commit treason, which is also an issue of today.
Just a little bit.
But then some of the requirements ended up falling through. So the spacecraft would have been nuclear powered with little tiny RTGs, little tiny radioactive balls that give off heat that create energy. And it turns out putting radioactive material on top of a Russian rocket was an issue. And so the U.S. government said, no, that's not going to happen. So that was canceled.
I can see that.
Yeah. Maybe if we were better friends, instead of more like frenemies as we have been.
Yeah.
So that was the Pluto fast flyby. Well, finally, we get to some names that sound less bad. Less bad, not good.
Okay.
Still less bad.
I'm ready for it. I'm excited.
The Pluto Kuiper Express.
Oh, that's fun.
The PKE.
Sounds like
guess.
Hogwarts.
The Pike.
What's
the Pike?
The Pike. Pluto Planet.
The Hogwarts Express.
Kuiper
Yeah.
Hogwarts Express.
Hogwarts,
But there are no chocolate frogs on this one.
Oh, boo.
Yeah.
Oh, that's their loss.
So the resurgence here was because astronomers were discovering more Kuiper Belt objects, asteroids, comets in the Kuiper Belt, the region around Pluto's-ish orbit. And so there was a resurgence in interest. So, okay, let's try this again. So Alan Stern this time brought on the legendary Gene Shoemaker. And if you're a fan of astronomy, you know Shoemaker from Shoemaker 99. Yeah, what was that?
That
really
was the
quick.
comet. That was a comet that hit Jupiter.
It did. Broke up into
and it
different
broke
parts.
up in different parts, and we saw the impacts in its atmosphere.
Yep. So Shoemaker is this legend in the field. So you get him on your team, you're doing much better. But for various reasons, a lot of it due to the radiation protection requirements that NASA had JPL put on. The cost again, balloons. Because when you want to harden these objects with radiation protection, you're going to balloon the cost and also the weight, and that increases the schedule. And which is weird because you didn't necessarily need that radiation protection in the outer solar system because you're not getting that close to Jupiter. So in the book Chasing New Horizons, Alan Stern kind of says, well, we think that was JPL and NASA's kind of putting the kibosh on this Pluto mission. It's just loaded up with radiation protection and it'll be canceled. Lo and behold, the price ballooned to $1.5 billion and it was canned.
I mean, that's not bad.
$1.5 billion? Well, that was also 1998 money.
Okay.
It's probably about $2.3 billion now.
All right.
Ish.
Yeah, it was what, $2.4 billion for Curiosity?
Sure.
Mars, I think it was.
Sure. Like the whole mission? That's about, okay.
Yeah.
Cassini was in the billions.
Cassini was a huge cost overrun. It was lucky it didn't get canceled.
James Webb's in the billions.
Well, it's
And James Webb would not be
over
canceled.
budget.
Oh,
Yeah,
it better not be canceled.
All right.
It's not. By this time, it's good. James Webb people, you're good. So that was 1998. And it looks like interest died down. But then all of a sudden, we had two events happen. Number one is Ted Nichols. Ted Nichols was a 17-year-old kid who went on this crusade for Pluto by himself. Like, nobody contacted him to do this. He just started up this social media campaign before social media was a thing.
I was going to say, what year is this?
What year is it? This was 2000-ish? Maybe 1999?
There was no social media at all.
No.
AOL.
AOL.
He went on all those message
he went
boards.
all the chat
Yeah.
chat rooms.
Chat rooms.
But
Hey, we go to Pluto.
Oh,
Drink.
that's a drink.
But he drummed up interest. And also at the same time, the Planetary Society, they got 10,000 letters from the public and delivered them on the doorstep to Congress. So you have this 17-year-old kid who literally marched up to NASA headquarters with the press right behind him and said, hey, why not Pluto? And then you had these 10,000 letters, so interest again got going in Pluto. And that's when an open competition began in the year 2000. They had 3 months to build a proposal for the first selection, and as they're getting going, right away, it's canceled. That's until Senator Barbara Mikulski, who was like the saint of astronomy, stepped in to revive it. Bless you, Liz. So this competition started back up.
We're recording this.
Yeah,
I know.
There's going to be a sneeze in it. I can see
And then-
it.
and then-
Do we now have to have a sneezing drinking game?
No.
That'd be good, though.
Continue, Brandon.
So I'm trying to go fast because history is fascinating, but also takes a while because it's history. So
There's a lot of it.
there's a lot of
lot of
history, guys, to
history.
talk about. So this open competition was eventually down selected to 2 groups between APL, the Applied Physics Laboratory
I was
up
gonna
in
say,
Baltimore.
I've never heard of APL, and I think it's hilarious that there's an APL and a JPL, and I want to call APL Apple.
Well, Apple, as it comes, it was more defense, but also had one really successful interplanetary mission called NEAR, which is to near-Earth object asteroid.
Oh, yeah.
But it was super impressive because it came in under cost and ahead of schedule, which is just mind-blowing in the space industry. So APL, even though they're kind of new kids on the block compared to JPL in space, they had the good graces already. So you had the one-on-one, APL, the new kids on the block, and JPL, these legendary missions, these incredible staff that go head-to-head. And as these 2 teams are kind of duking it out in the proposal stage, all of a sudden, 9/11.
Ugh.
Right? All the
Fucks
things that...
everything up. Goddamn 9/11.
So APL had to be closed down because they were really close to DC, up in Baltimore. But they did get a couple weeks extension to go finish the proposal in a different laboratory. So you can imagine if you have essentially years of work crammed in this tiny office, into this general office, and all of a sudden had to relocate to finish your project with 2 weeks left. Imagine that stress.
The terrorists
That's
did
insane.
not think about everybody that would be affected by this. They didn't think about the space missions.
Wow. No, clearly they did not.
God, what jerks.
Just want scientific truth.
Jeez.
But at the end of the day, APL won out, and APL's team, when they got the call, happened to be in New Orleans, and according to the book, they all got shit-faced in Bourbon Street.
I mean,
I would.
Yeah, that's
Yeah.
legitimate.
So, with this history of Pluto missions being canceled and changed, literally the first thing that happens, like 3 months into it, is it's canceled due to cost overruns. Which is crazy, because I haven't started, and there were no cost overruns.
What?
So this was either a couple things. Either the Bush administration saw this Pluto mission and thought it was a prior Pluto mission that was over budget, or it was a conspiracy theory and JPL kind of leaned politically and said, cancel this mission because we want it. But then what happens? The patron saint of astronomy, Barbara Mikulski, steps in. She gets it taken care of. And long story short, eventually it gets top priority in the decadal survey, and they get the go-ahead to launch. And the very last window in 2006 to get there before the atmosphere freezes over. And we all live happily ever after. Because now we actually get to talk about what New Horizons found and Pluto itself.
Wait, you didn't even introduce New Horizons.
I didn't. Oh my God. So New Horizons is number 1. Sorry, New Horizons is, of course, the mission of APL that was chosen to go to Pluto. And unlike the naming process of Pluto, New Horizons was thought of, the name, by Alan Stern. He was kind of throwing all these different names around with his team because he needed something great.
It is a good
So the first name was like, no, not the first name, but the second to last name was New Frontiers. But that has political connotation with the Kennedy administration in the 60s. Yeah.
Well,
And so
it
he
has
was.
a lot of historical background with
It does.
frontiers in this country.
Yeah. Also, Frontiers from Vannevar Bush, who does science policy, but that's a different podcast. So he was driving home in Colorado, and as he says, he looked at the Rocky Mountains with the sun setting and saw the horizon. He goes, wait a fucking minute! New Horizons! And he stuck with it.
Was that an exact quote?
I fucking knew it. New Horizons. Yeah, that was an exact quote. But New Horizons is very similar to the original concept of Pluto 350. The same, very similar bus construction of spacecraft. Only a very limited amount of instruments that were already proven. So you're not developing technology. And it flew off January 19th, 2006 to go do the gravity assist from Jupiter, the slingshot, and zip out to the farthest reaches of the solar system.
Amazing.
Is it really the farthest
It's-
reaches?
it's
Not the
not.
farthest reaches.
It's
if
not
you want to be
technically
then,
correct.
But then that could be an issue because we think Voyager has left the solar system. But then when we talk about the Oort Cloud, it still has like 3,000 years to go.
I thought I went past the Oort Cloud and left.
Kuiper Belt.
No,
well,
Kuiper Belt.
No, the
The
Oort
heliosphere.
Cloud's like
Heliopause?
halfway
Heliopause.
between us and...
Well, then the Oort Cloud's still in the solar system, yeah? Because it's like a hamster bubble of a hamster bubble.
It's still within the influence of the sun. A
Yeah.
hamster wheel.
Hamster wheel. That's what I was going for. Hamster ball.
Yeah, but you could make the argument that Alpha Centauri is within the gravitational influence of the sun.
Is it?
Not like a planet is,
no.
but
No,
it
I
still
thought Voyager
feels...
left the influence of the sun.
Right, it's in...
The heliopause. The solar...
It is in interstellar space.
Okay.
Right, so really quick, I think the difference there is that the number of solar wind particles from other stars outnumbers the sun's solar wind particles.
Okay.
That was basically
the sun is not the
there.
dominant star in.
There we go.
Right.
Yeah.
All right. So now I think we can finally talk about Pluto. Now that I talked about for the last hour how we got to Pluto, and I zipped through the last part really fast.
You did great. It was the Pluto Express flyby.
Hey, clever!
Information.
Well done. Well done, Liz.
Yeah.
I can put my notes away and just listen to you guys talk.
Yeah.
Oh no! Break those notes.
No,
notes
that's not how it works.
No, we're gonna all work on the same notes here, and at least on the outline.
Okay.
Anyway.
Well, what's next? New Horizons.
New Horizons. So we'll talk about New Horizons, but I'll actually come back to kind of what we know about Pluto in a moment. But the New Horizons spacecraft itself, like Brandon said, Alan Stern had to lobby for it, and eventually got the funding for it, and we launched on January 19th, 2006 from Cape Canaveral on an Atlas V rocket.
That was before I moved to Arizona.
Okay.
Sorry, just personally, a personal milestone, just for myself. I moved to Arizona in June of 2006.
Okay.
Okay, so.
Fascinating.
So,
Wow.
Liz is still in California at this time,
Yes.
California.
Yeah.
but will eventually make her way to Arizona.
Yes. That's where I meet these two hooligans. So.
I know, right? So, to me, I guess when I think of spacecraft, I think of Cassini, which is this friggin' bus-size object, school bus-size object. New Horizons is actually kind of small. It's really only 7 feet by 7 feet by 9 feet.
Wow, it's really that small?
Yeah, and weighs about 1,000 pounds.
That's
So more than
not-
350 kilograms.
Yes. Pluto 1000.
Yeah.
Hey.
So so it's actually it's much smaller than you think.
God,
And
I just assumed all those satellites were just
Massive.
monumental.
I know, right?
size.
I know, right? Like I said, I always think of Cassini-sized objects when I think of the spacecraft, but Cassini I think is more of an outlier. But anyway, it is the 5th spacecraft that actually has the speed to leave the solar system.
What's its speed, Mike?
What's the speed? I think it's like 36,000 miles an hour.
Mm-hmm.
I want to say. I want to say 52,000 kilometers per hour. Anyway, that speed will take New Horizons from New York to LA in 4 minutes.
Oh, why can't we have that transportation?
I want
That
that.
would be nice.
I want that for when we go visit your parents.
Yeah.
I want to get to your parents in a minute.
In a minute, just hey,
We'll see you in a minute. And we literally are there in a minute.
And then he can also leave really fast, too.
Yeah, exactly. Argument starts happening at the dinner table just so we're out.
So Brandon might actually be able to correct me on this, but at least for stabilization, it uses hydrazine, which was a drink we had last time, to stabilize it so that it can like point its cameras and stuff like that.
That's like in the movies when you see those little splurts coming out of the spacecraft. It's like
exactly. Yep. But it uses pressurized helium for other propulsion. So
so miscellaneous other.
And when you talk about other types of propulsion, something that the New Horizons did to save cost, as opposed to like Cassini that has a swivel camera that can change its camera just on its bus. The New Horizons has to move its entire body to get pictures. So as it's passing Pluto and Charon, it's constantly going back and forth, back and forth. Just like that, Liz. Just like a mine. Trying to uphold the wall.
My hands are the satellite dish.
All right, so we just got a
question.
We just got a question from Twitch. It says, hi, first time caller, long time listener. Is Pluto the biggest Kuiper Belt object? Also, that guy behind Brandon.
He's random.
It's random guy behind Brandon is cute.
So, for those of you listening to the podcast, since it's primarily been a listener, an audio format, in all of these podcasts, because we Skype with each other, a cutout of Smeagol, also known as Gollum, is behind Brandon's shoulder.
Are there any other known aliases?
I don't know what his hobbit name was.
Smeagol.
Oh, was that his hobbit name?
What is his hobbit name?
Of course, okay. Just Smeagol, Gollum.
Smeagol / Gollum.
Gollum.
Is it Sedna that they thought was bigger, but turns out is actually
well, they thought something was bigger than Pluto that we'll get into later. That then
was it Alan Stern's ego?
Yes.
Just kidding.
So.
Alan Stern's pretty awesome in general, also, but it's funny.
So it turns out Pluto is the largest Kuiper Belt object, isn't it?
Yeah, but
I think so.
Yeah, it was. There's one Eris.
Well, we'll talk about that. Spoilers. #spoilers. We're going to talk about that because it's going to lead to some controversy, some scandal. That is still debated today.
Oh, wow. There really is no debate. But anyway, so the power that, to make its power, New Horizons uses the radioisotope thermoelectric generator to generate its power.
Radioisotope thermoelectric generator.
Yeah, like radioisotopic. RTG.
Yes,
okay. RTG. They're like wonderful tiny blueberries that if you eat, you die. But they're just the coolest things. But also, I found out when you add RTGs to a spacecraft, like Curiosity, for example, because Curiosity is RTG powered, it adds about 135 pounds of weight. Because it's not just those tiny RTG balls; it's all the equipment you need to transfer the energy from heat to actual energy. Okay. Yeah, so that's a lot.
So basically, for those who don't know, an RTG will take the heat from radioactive material and turn it into electricity.
Okay.
Thermoelectricity. There's no moving parts to these things, and so.
Well, also, because this is fun, RTGs, I believe, are made out of plutonium. And plutonium is named after Pluto, so it all comes around.
Gosh, it's like Inception. It's Pluto Inception.
Pluto Inception. Nice.
Wow.
All right, so
anyway.
So it launched in 2006, and New Horizons is going so fast that in a year later, 13 months later, it passes by Jupiter.
Oh, it's like
so fast.
Yeah.
Jupes. Bye, Jupes.
I mean, it literally is like, hey, and then we're gone. 1.4 million miles away from Jupiter. Use Jupiter as a gravity assist
okay.
on out to Pluto. But they also used it as an opportunity to check instruments. So it actually acquired data on the moons, the atmosphere, the magnetosphere of Jupiter. And then it basically went to sleep.
It was like, all right,
Right.
I got a long journey ahead of me, so I'm going to take a nap.
Well, actually, that was one of the big selling points in New Horizons as well, because on the transition point from Earth to like Saturn with Cassini, you still kept 450 people on staff, whereas when you go to hibernation mode, you see a skeleton crew of like 50 people, which significantly saves cost.
Yeah, that's true.
Right, but eventually it has to wake up. And it did.
Right. A kiss from a prince.
Yes. Only by a kiss from a prince.
Oh, okay. Yeah, go on. We're getting the good stuff.
So on December 6th of 2014, New Horizons wakes up. It's taken out of hibernation
very exciting.
mode for a Pluto flyby. A month later, it really kind of gears up for it. And then on July 14th, 2015...
Wait. Let's go back to July 4th.
Oh, yes, July 4th.
Yeah. You remember where you were at when you heard about it? I was in the planetarium.
I don't remember.
No, you
I was
weren't.
probably in the planetarium.
I wasn't? I thought I was.
No, yes, you were. You were in the planetarium.
Okay, thank God. What happened July 4th, Mike?
It goes into sleep mode. Basically, it shuts down. It has there was. Oh, Brandon wants to say.
Go for it,
Oh
Brandon.
no, I would put more context behind it. This project you've been working on for literally 25 years has gone to hibernation mode a fucking week before you get to Pluto, and you're like, oh shit,
You're like, no!
Everything's fucked. Everything is fucked.
Right. So July 4th, the New Horizons goes into sleep mode, and on July 7th they were able to get it back. That was a long 3 days.
Look, New Horizons has been traveling a long distance. It just wanted a little power nap. All right, it just needed a little power nap as a refresher because it's got some real work to do.
It was sleeping for like 10 years,
Well,
man.
you know when you wake up from sleep and you're really groggy and you're kind of like, I just want to go back to bed. So it just did that. It just got a little extra. It just hit snooze.
All right.
A little extra 5 minutes.
But man, this is the day before the biggest moment of your life.
Right.
You don't click snooze, man. You're ready to go.
Right, so it goes
Horizons
on July
doesn't have
4th, it
feelings.
goes into sleep mode, and you know everybody's freaking out.
Yeah, because...
You know you had the 7
It's a
minutes
lot
of
of
terror
time.
for Mars. This is like 3 days of terror for the New Horizons crew. You spend all these billions of dollars to get there. These many years, these decades, that people have dedicated their lives to get to Pluto.
Oh my God.
And then 10 days before, hey, we're just going to go to sleep. You know? But on July 7th, they did get it back up. And on July 14th, 2015, was the closest approach to Pluto. 7,800 miles.
It was so great. Oh my God.
Oh, so can we learn about that?
Where were you?
Oh, I was not technically in a planetarium, but I was talking to people about Pluto, watching the live stream come in. And so every new picture that we got, I would just throw it up on the screen and go, let's talk about this for a while, guys.
God,
And
like-
so amazing. I was in
Whoop.
the planetarium.
Liz, where were you?
I was in the planetarium.
No, you weren't.
What?
You were in Maui.
I was in Maui?
We were
You're in Maui? What the fuck were you doing in Maui? This is the biggest day of your life.
Was I
We
in
were in Maui.
Bro.
Oh, wait a minute. This is when like Mike was in like South Carolina or something.
Oh, that's right. I was in Maui. You were in South Carolina.
Yep.
I was.
were.
So
And
for
to
those
our
of you-
listeners, we were both in Maui.
Yeah.
'Cause we worked
Also,
together.
if you're confused, I wasn't allowed to know they were together yet. So
He didn't know.
somehow
And he
this
was
friendship
totally
persisted
convinced-
even though it's lied to.
Totally convinced that we were both in separate locations at the exact same time.
But that's a side story to the main story of Pluto.
Anyway.
Oh no, this
Just
is the
how-
real story.
But when I got back to the planetarium, throwing the images of Pluto up on the dome was the most amazing thing.
We remember we had this 60-foot dome, and Liz got back and she put the highest quality image she could find and just covered the entire sky with
my
Pluto.
God.
And it was the coolest thing.
We're past foreplay. We're into the porn. It's Pluto porn.
This is Pluto
all
porn.
over the
Straight
up.
dome. It
Yeah.
was beautiful, and the reaction from the audience members
The
was
audible gasps.
yes, they were blown away, because you have to remember that, you know, in the past, basically the highest resolution image of Pluto we had was just this blurry, grainy, pixelated
And that was back
image
in
of a circle.
and that was still back in 2006, so fairly
Yeah.
recent with the Hubble.
And this is like, you know, the pictures we see of Mars. You know, you could see
It-
mountains, you could see details on the surface, and it was
It becomes a real
absolutely-
object.
It becomes just not just this thing in your mind.
It's-
it's Pluto. This
it's
is
like-
real.
Right? It's like seeing a sonogram versus an actual baby.
Yeah.
Wait a
like,
minute, this is
oh,
an actual
This is
thing.
a real baby. This
Let's
isn't
live it
some
forever.
mutant alien inside of me.
Let's live it forever and always.
Yeah. So, what's the iconic picture of Pluto?
Oh, of the heart.
Of the heart.
Of the heart.
Tombaugh Regio, yeah.
Right. So if you Google Pluto and New Horizons, inevitably you're going to see the picture of this heart-shaped object on Pluto.
Mm-hmm.
And I mean, in all honesty, to go from pixels in 2006, go from pixels, circular pixelated thing,
Mhm.
to, oh my God, I can see this heart-shaped object, which, by the way, is the largest glacier in the entire solar system,
Mhm.
which is the size of Texas and Oklahoma combined.
Oklahoma.
Hey.
Yeah, I wouldn't get too excited. I've seen live PD. I wouldn't get too excited.
Okay.
No, but and mountains, plains, and craters. Pluto
An
comes
atmosphere.
and
It comes
atmosphere.
alive. It's this dynamic world. It's not an object in our solar system. It's a world in our solar system. It's amazing.
But it's
beautiful.
even more dynamic because if you look at the plains
Mhm.
of Pluto, there's evidence, or it looks like there is evidence for convection,
Mhm.
which means that you might have a liquid water ocean up underneath this
Would it
icy
be liquid
surface.
water?
Yeah,
yeah.
ice
Liquid.
ice water
Okay.
is ice water. It's kind of.
But at these temperatures, ice water is harder than any rock here on Earth.
Right, but for if I understand correctly, for Pluto, there's actually water in it,
Oh, I thought it was like the nitrogen.
actual water. Now, for its moon, Sharon,
Sharon.
or
Sharon.
however you want
It's
to pronounce it,
Sharon.
Sharon.
Sharon, like Ozzy would say.
I was just gonna. I had that in my head the whole time. Is just Ozzy yelling, Sharon!
And I stole it from you. I stole your
did.
thunder.
You did.
So, like with Sharon Osbourne, it's solid ice in the middle. They think that there used to be some water, and now it's solid ice. But for Pluto, with that convection, though, convection is an up and down movement. So you need to have something that's moving it.
Uh-huh.
Water, possibly.
Uh-huh.
Possibly. So the internal structure of Pluto might be this rocky core, and then this kind of water, mainly ice, mix above it, and then of course the surface is solid ice,
Mhm.
and then you have, of course, this very thin atmosphere around it. But that's on the plains. There are craters.
Mhm.
On Pluto. There are mountains that rival the Rockies in
Mhm.
height.
Does it have cryovolcanoes?
Oh, cryovolcanism.
Does it?
I don't.
I don't know.
I thought there was inklings that it could have some
I think
cryovolcanism.
there were inklings, but I don't know for sure. So I'm not going to go into what I think
Okay, so
because I might be
audience,
wrong.
maybe
Well,
ice volcanoes is what that
Right,
means.
possibly, but what I've seen as far as like the the plains, which is a very young surface, it could be. It looks like it's frozen nitrogen.
Right. So there has been at least some resurfacing that has gone on.
Oh,
Right.
absolutely. So when you say new surface, you know that because number one, you look at the surface and it's not pockmarked full of craters. Like you go look at the moon, craters everywhere because the surface is extraordinarily old. Whereas Pluto's surface with the in the plains, the Tombaugh Regio, they're estimating it at below 100 million years old.
Wow,
Which is
young.
yeah, it's
And-
very like
and to
its skin's
quote
still
NASA-
stretched out, its pores are small, it looks good.
And to quote NASA, the degree of current activity on Pluto's surface and the youth of some surface on Pluto were unexpected.
Yeah.
So
Totally.
there's a lot that I mean, in all honesty, when you've explored Pluto, you're basically looking at pixels, little square pixels, and so I think a lot of what they found was unexpected.
Yeah, because I mean, well, that square, the previously our images of Pluto came from Hubble, correct?
Yep.
Because that was the most powerful telescope that we've had because it's in space to capture images of Pluto. We haven't ever had anything out as far as Pluto, or I should say, to fly by close to Pluto to get high resolution images. So,
Right. Now, when you think of like the picture that Hubble took as like a 1992 video game.
And now it's today Assassin's Creed Odyssey.
Exactly.
Yeah.
That's how far we came.
Yes.
And
How close we came.
Exactly, 7,800 miles. And just some of the things that we've learned from Pluto from New Horizons was, like I mentioned, the degree of current activity on the Pluto surface and the youth of some of the surfaces on Pluto was unexpected. Pluto's atmosphere hazes and has lower than predicted atmospheric escape rate, which means particles of the atmosphere escaping the planet. Go ahead.
I just wanted to point out as well how crazy it is to have a planet so far from the sun to still have an atmosphere, even though technically it was in its summertime, so it would have been in its fall time because it was getting close, to still have an atmosphere that freezes and then reacclimates and then freezes and then reacclimates over the course of 246 years.
Right, and so basically Pluto has this really funky orbit where it so if you remember, class, Kepler came up with 3 laws of planetary motion, and one of those laws was all planets have an eccentric orbit.
Wait. He said all planets, right?
All planets have an eccentric orbit, but we'll also include asteroids, comets, some comets.
So no orbits are exactly circular 360 degrees. They're elliptical. They're oblong. They're egg-shaped.
Actually, I don't think there's a planet in our solar system that has an eccentricity of 0, which would make it a circular planet. So a circular orbit. But Pluto, and all 8 planets in our solar system, 8 have eccentricities very close to 0, which means they're very close to a circular orbit. For the Earth, on average, is 93 million miles away from the sun, which means that it can be, with its eccentricity, it can be as close as 92 million miles or as far away as 94 million miles. So that difference is really quite small. For Pluto is very different. And before New Horizons, astronomers looked at, they're people too, right? Yeah, sure, why not?
Yeah, weirder people, but people.
They looked at Pluto and they knew Pluto was different. It has a very inclinated orbit compared to the other planets in the solar system at the time.
All the other planets are on the same plane. Pluto's is tilted to 5
A
degrees.
little bit above it and below
the
it.
plane of the solar
Its
system.
eccentricity is greater than the other planets, so its orbit is not as circular. It's more elliptical, more oval, if you will. And Pluto's orbit is so extreme that it actually crosses.
No.
I have an asterisk on this. It crosses Neptune's orbit.
But never in a way that it will run into Neptune, or Neptune will run into it.
No.
Yeah, it's just, yeah.
No.
So no Pluto-Neptune collision at all.
Yeah, so that actually will never happen. So prior to 2006, the great IAU meeting in 2006.
International Astronomical Union.
It's basically like the Wizard of Oz. Basically, you look behind the curtain and it's this guy who decides everything.
Wizard of Astronomy.
Wizard
of Astronomy.
Which Liz will get into in a bit. Foreshadowing. What do you call it? Not foreshadowing. Is it foreshadowing?
Sure.
It's foreshadowing. You can go with that.
Foreshadowing.
So,
I guess at that point when you straight up say it, it's not foreshadowing. It's like, hey, there's a gun on the wall. It's going to be used in Act 3. At that point, it's not so much.
Obvious spoilers.
Well, okay. All right.
It's fine.
All right. So, where was I? I don't even know where I was anymore.
I don't know. Pluto's orbit is highly elliptical.
Yeah, so it crosses Neptune's orbit. So we knew that it was
a trans-Neptunian object, if you will.
Ooh.
Nice.
Ooh, we'll talk about that later.
That's an objective
Can I shorten
term,
that
class.
to P&O?
P&O.
You can.
T.
Oh, T&O?
T.
T-No?
and O.
Damn it,
That's what we call an initialism.
All right, so crosses Neptune's orbit for only 20 years. And it last happened from 1979 to 1999.
Yep. So when I was learning about the planets in my grade school, because, Neptune was technically the last planet in the solar system. So that's why Neptune is my favorite planet. And now since I learn more about Neptune, there's a lot more reasons why it's awesome. But it was the last planet, so it was my favorite.
And for me, who's older than all you people.
Yeah.
Put together. Just kidding.
That's fucked up.
Anyway, Pluto was the 8th planet before it was the 9th planet, and then it went back to the 8th planet.
The 8th planet.
And then it went to the final planet again. So, all right. Anyway, all right. So Pluto, it does have an atmosphere. When it's close to the sun, that atmosphere is active. When it sublimates and becomes an atmosphere,
And it even develops a bit of a tail, like
A comet!
what?
Hold the fuck on!
What?
What are you saying, Liz?
Pluto has comet behavior.
What?
Yeah.
All right. Well, I'm sure she's going to talk about that later.
Am I? I don't know. We'll
I'll
see.
talk about it because I'm ready to go.
Anyway, as it goes further out, it sublimates, and when it's close, it sublimates, becomes an atmosphere, and then it freezes out when it's further out. At its closest point, Pluto is about 30 times the distance between the Earth and the Sun, so 30 AU.
Doesn't sound too bad.
3 billion miles, roughly.
I mean, yeah, that's a big distance that no one can comprehend. But
So
in universal distances, it's pretty close, but it's really far away.
So how many times would New Horizons have to say, and I would walk 1 billion miles, and I would walk 1 billion more? So he had to say that for like a minute.
It just went continuously on loop in the spacecraft. Every time it hit 1 billion miles, it would play that.
Well,
I would love to hear that.
that would be cool. That would be cool.
If I was one of the engineers, I would program that shit in.
All right. Well, at its closest point, it's about 30 AU out.
Okay.
At its furthest point out, it's about 50 AU out.
Woo.
So that's a really big difference.
Yeah,
You're talking,
Right.
that's a difference of about 2 billion miles.
it's a big egg.
Yes, it is. Yes, it is. Our egg, the Earth's egg, it's only 2 million miles.
Yeah.
This is 2 billion miles.
Yeah,
that we're
that's a
talking
lot.
about. So, So other things that we've learned from the New Horizons spacecraft, Sharon.
Which I love, by the way. Sharon was supposed to be called Oz at first, so it just all makes sense.
Perfect.
Discovered in 1979, by the way. Sharon.
You were 10.
I was 10.
This is when the drinks are getting to us right now.
Yes.
You were -6.
I was -6. I love that. At this time, I was -6 years old.
I'm Emily Watson.
And I was
God.
6 years old.
I hate all you people.
Well, I love you forever.
No, you don't. You say that because you have to, because in 2 days, you know what happens in 2 days.
Whatever.
All right, so, sorry, anniversary.
I married you, and I will unmarry you right now.
With the powers invested in me, Brandon.
I now pronounce you divorced.
Oh, is it that easy?
That would make a really easy divorce.
I know, right? All right, I have other bullet points.
Okay, continue.
Just kidding.
Continue.
I mean, I do have other bullet points. Sharon is moon of Jupiter. Sharon's enormous equatorial extensional tectonic belt.
That's another
You're
change.
not reading that from a note.
No, I told everybody I'm reading from a note.
Bullet point.
Hence that, basically it hints that Sharon might have had a liquid water kind of ocean underneath its surface, and it's frozen.
It's frozen now.
It's now frozen. Whereas for Pluto, there's hints that there might be some sort of water up underneath the surface.
Right.
It sounds familiar now. Okay.
Yeah.
I'm on board.
So all of Pluto's moons can be dated by looking at the craters, and they all have what appears to be the same ancient age, adding weight to the theory that they were formed together.
Okay. And Pluto has Charon, Nix, and Hydra?
5 moons.
Five altogether.
5 altogether?
Charon, Nix, Hydra, Kerberos, and...
Yep.
What's the last one?
Kerberos.
Cerebros.
Styx.
Styx. How can I think Styx?
All related to Hades, the Roman god of the underworld.
So Sharon has this dark red polar ice cap.
Oh, it's so cool.
Which is a bit unprecedented in the solar system. And what they're thinking is that it's a result of atmospheric gases that escape from Pluto that have accreted onto Sharon and created these.
Oh, wow.
Yeah.
That's cool.
It sounds kind of like Tholin.
Exactly. And so, Brandon, as you drink your Tholin, what is a Tholin?
You know what, honestly...
It's not a dwarf.
It's not a dwarf. It's not the son of Gloin. Or as, I don't know what you called the grandson of a dwarf.
I don't remember.
Grandorf.
Grandorf. Yeah.
Grandorf.
But at this stage in the podcast, I cannot say exactly what Tholin is. However, I can say where the name came from. So this was back with Carl Sagan when he ran an experiment to try to create essentially light from organic compounds with lightning. That's because that's how life supposedly got started here on Earth, or maybe on Mars with panspermia, but that's a different podcast. And as they were trying to create this goo came out that they just called Tholin because it was organic, but it wasn't life. So it's just this gunk.
It's organic material.
Yeah, organic material essentially.
Now,
and when you think of organic, yep, there you go. Go ahead.
Organic does not equate life.
No.
All life as we know it has organic material in it, but having organic material in a petri dish does not mean, or on the surface of a moon.
Right.
Bingo.
All right. So, like I mentioned, Pluto has a heart-shaped thing, object, which is the largest glacier in the entire solar system that we know of.
Thanks, global warming.
No global warming on Pluto.
No. So Pluto shows evidence of, some vast changes in atmospheric pressure. It also shows evidence of past volatiles being on the surface. Now, liquid volatiles, we see the same thing with Mars. There's only 4 objects that we have seen this with, and we have seen it, of course, with the Earth. We have seen it with Mars. We've seen it with Titan, the largest moon of Saturn.
Titan.
And now, with New Horizons, we've seen it with Pluto.
Ugh.
Can you explain further on what it means by volatiles? What you're... No?
like they have really
quiz!
bipolar personality. It's very volatile.
Explosive. What does liquid volatiles mean?
Well, I think it's like liquid water on the surface, or this briny.
Oh,
water
briny
on the surface.
Love briny water.
Yeah, and so
Delicious.
when you're on an object that has very thin atmosphere, Mars, Pluto, whatever, it really doesn't quite stick around. It's very volatile.
Oh, okay. So it's not a permanent feature necessarily. It can be it can fluctuate.
It's volatile.
It's volatile.
Pluto has 5 moons. When they were going to have New Horizons fly past Pluto, they thought they might find more. And so the lack of additional moons was unexpected when they found it.
I love the concept of moons, which moons really are satellites. That's the actual definition of a moon, is a satellite, an object in orbit around another body.
So,
Exactly.
okay, sorry. I'm not going to go on the Lou Reed tangent. Don't worry.
Okay.
All right, so it doesn't have a ring system, which to me is not so much unexpected. But they thought maybe there possibly would be a ring.
I would never think Pluto would have a ring.
No, and it might be this 50-year-old brain that goes, oh, the big gas giants have this, and so
yeah, but it doesn't seem like it would have had the
ability to rip something apart.
Well, it's maybe not necessarily rip something apart, but
Collisions?
because collisions, exactly right, with the debris flung out. But at the same time, how heavy those impacts would have been, if they were heavy enough to create a Saturn-like ring, would have torn Pluto apart, I would assume. So, speaking of that, I'm not sure if we're going on this path, but Charon is kind of equivalent size to Pluto. It's coming in like 0.1 of Pluto's mass, which is massive for a moon.
Right.
How did Charon come into being?
Well, they do think that came from a collision.
Okay.
And so
that's also similar to the Earth's moon, because the moon, I don't
The
know
moon.
when that happened. The Earth, I combined Earth and moon. The Earth itself is not large enough to have enough gravity to capture a moon of that size, a satellite of that size,
right.
And so really the only possible way would to have been a collision and then the pieces forming the moon.
Right. I guess I might say that you could also have them form together.
Okay.
But the evidence doesn't point that direction, no matter what an astronaut might say. But yeah. So anyway, Charon is. How did I get all the way up there? But Charon is about half the diameter of Pluto. And so there's this thing called the Barry Center in physics, which is...
Keep talking.
Think of it as like the center of mass of 2 objects, and they orbit around the center of mass. And if you look at the Earth, the Barry Center for the Earth and the Moon is actually inside the Earth. For Pluto and for Charon, it is
actually outside of Pluto. It is between the 2 objects. And so astronomers like to think of Pluto and Charon as this double planet type object.
Binary planets are the coolest
binary
things. Like
planets.
So
I know we
cool.
talked about kinks earlier, but binary planets are totally my kink.
That's so cool.
And what's really cool about Charon and its relationship with Pluto is that the 2 are tidally locked to each other.
Oh, wow.
So one day on Pluto is about 153 Earth hours long.
Okay.
It takes
Wow, that's a long
Charon.
fucking day. It's
I know,
a
right?
long fucking Monday.
1 day on Charon. Well, the amount of time. Well, 1 day, and the amount of time it takes for Charon to go around Pluto is also 153 hours long. So if you were on Pluto and you had Charon above you, it would always be above you.
Mm-hmm.
If you were on the other side of Pluto and you didn't see Charon,
Never see Charon.
you would not know it's there.
Wow.
What a depressing life that would be.
I know.
I know, right?
Until you invented, space technology, and then you'd be like, oh shit, there's a fucking moon over here.
So, Pluto, as we have mentioned, has an atmosphere.
I love that. Sorry.
Thank you. I appreciate.
All right, so as we mentioned, Pluto has an atmosphere. It has a very thin atmosphere of nitrogen, methane, and carbon monoxide. And what color is the atmosphere?
I know it because I know it, but I also saw your notes, but I also know it.
What is it?
What is it, Liz?
Blue!
It is a blue atmosphere.
It's amazing!
Yeah.
Pluto.
Bluto.
So Pluto has a blue atmosphere.
Pluto blew itself.
Move.
Oh, there you go.
Oh, there's this very iconic image of Pluto's atmosphere from
Oh,
New
so
Horizons.
cool.
From behind?
From
Yeah,
behind
yeah.
Pluto, and you can see the atmosphere, and it is the most beautiful image.
It really is. And, the thing is that New Horizons took us from this world of pixels, like we're playing Pac-Man. It's this world of pixels to a real object. It does not fundamentally change how I view Pluto.
No, but Pluto becomes this dynamic world, when you would think it would just be a frozen ball way out there in our solar system.
That's what we expected, yeah.
Yeah, but there's so much interesting attributes to it that it's beautiful and amazing and complex, and it's its own thing. Yeah.
And then while we're still kind of talking about New Horizons, before we get into planethood, remember the next year on Christmas, New Year's Day rather, it passed by a Kuiper Belt object. Remember that one?
Yeah, because that was this next, after they went to Pluto, they were like, all right, well, we still got some juice. Where are we going to go?
2014 MU-69.
Yeah, so they
MU-69
to go to another object out there in the Kuiper Belt, where Pluto is hanging out in, which we'll discuss a little bit further in the next section.
In the next hour.
MU-69.
Right, and before we get to Liz's next hour, I think that the story of Pluto really is the story of science.
Oh, that's deep.
Yeah, as we learn, we change the way we see things.
Yeah, exactly, and that's the point of science, is you're not stuck in one predetermined mindset. It is ever evolving and changing based on new information.
So, wait. I guess you could say that science is relative. Damn!
And on that note, it's time for us to take a quick break before we get into the Pluto scandal, the controversy.
The scandal
over Pluto.
Ooh.
So
All right.
we'll
see everybody in a minute.
Time to go pee.
Previously we were talking about Pluto and what Pluto is and the amazing things that we've learned from New Horizons, but I would think that Pluto is unfortunately mainly known because of the controversy behind Pluto. And there are two sides to this controversy.
Yeah,
It
and
is
Team
Brandon.
Jacob and Team Edward.
Yes. So one shimmers.
Vampires do not sparkle.
Vampires don't fucking sparkle. God damn it.
They do now.
I will die on this hill. So Pluto, whether it's a planet, as a lot of us grew up with, or is not a planet, which is the most recent thing. And according to the International Astronomical Union, or
IAU.
thank you, Pluto is not a planet and hasn't been a planet since 2006, people.
August 2006.
Get over it.
I was 15 years old.
I was
I-
100.
I wanted to dig that in a little bit.
I don't know.
I was 100.
I was probably
Oh.
16 to be fair.
I was just I moved to Arizona. I was in my 20s. Some 20. I was 20.
You were 21.
I was 21. No, I was 20. I was 20.
It's
Oh, yeah,
kind of
you were 20.
it's really odd how Mike knows how old Liz was, regardless of the year.
No, it's just because he can do math really fast in his head, whereas I cannot. So I was 20, and I only know that because dogs, stop fighting, stop playing. I only know this because my first marriage was in 2007, right after my 21st birthday.
Okay.
That's how I remember that. So
Now we're getting back to topic of
Wait a minute.
anyway,
You were married before?
what?
What the hell? I did not know this.
So there was this.
Wait a minute!
We're gonna move past that. So there's this huge controversy over is Pluto a planet or not a planet, and it's because I think mainly because Pluto discovered in 1920, as we've discussed, by Tombaugh, and back then the telescope saw this, small object really far away orbiting the sun, and they're like, oh, of course, it's a planet. It's the 9th planet in the solar system. Hey, ho! But then, you're welcome. As time has gone on, telescopes, technology has gotten better, and we've been able to see more things, farther things. We've discovered many more things that are out by Pluto, hanging out with Pluto, so to speak. Things that are in roughly the same, that are spherical like Pluto, that have roughly the same composition as Pluto. And then it became where then astronomers were like, well, wait a minute. We're discovering all these new things out there. Is Pluto really a planet? Are these other things we're discovering, are they planets? Or is there another classification for these objects?
Or are they dancers?
They could be. I mean, everything is dancing around the sun.
That's
And
true.
the sun is dancing around the Milky Way. Everything's in orbit around other things. Anyway, so what we used to think of a planet is basically a spherical object. So an object that is massive enough to have a high enough gravity to form itself into a sphere. A sphere being the least energetic state for an object.
Ooh, look at Liz
Hey.
dropping it.
Breaking out the
I got
physics,
some physics.
baby.
I got some physics up in here.
Yeah.
So,
If you didn't go there, I was going to go there.
well, I went there. I got you, boo. So, Pluto is spherical and it orbits the sun. So, planet. But, so as we've discovering more things that are out there, this, far away from the solar system, other things that are spherical, and one really became the defining point, and that was Eris. So in 2003, there was an object spotted, and in 2005, it was actually confirmed in January of 2005. Eris, which was named after the goddess of discord and strife.
Aptly named.
Aptly named because it's going to cause a lot of discord.
Right.
Actually,
But-
at first, yeah, I'm going there, Brandon. At
Do it.
first, it was called Xena.
So who in their right mind changed the name from Xena?
An idiot. Because
Thank you.
Xena is amazing. I love Xena. I grew up on Xena. I met Xena last year at our FanX here in Salt Lake City.
We had the pictures.
And middle school me was just a light and joy because Xena's badass. So, and actually, it's interesting because if you've ever watched Xena Warrior Princess, this is what we're talking about, for those of you that are like, what's Xena? There is a character in the later seasons, there's a goddess that shows up on the scene, and her name is Discord.
No way.
Yes, there is a Discord character.
What was her, not sidekick, but life partner's name?
Gabrielle.
Thank you.
Gabrielle. Is played by Renee O'Connor. Of course, Xeno's played by Lucy Lawless.
Can we just make this a Xena podcast from here on out? Especially when they crossed over with Hercules, because that was just the best episodes.
Oh my god, I love the crossovers with Hercules. In fact, I started watching Hercules, and then they brought Xena in as a one-off character, and then it became its own spin-off show.
It's like Angel and Buffy.
Yes, exactly. Except reverse genders. I love Buffy as well. I realized later on in my life that I attuned to these strong female heroic figures because I was a female and I looked up to them. But anyway,
I love this show.
So Xena eventually became Eris, the goddess of discord. And it's because this Eris was discovered confirmed in 2005, and it was about the same. Well, actually, initially it was believed to be bigger than Pluto, which was holy shit. There's an object out there bigger than Pluto. Pluto's a planet, so has to be like a 10th planet kind of thing.
It's too many planets, man.
Too many planets. Later on, they discovered that actually Eris is about the same size as Pluto. Now, Pluto and Eris both reside in an area of our solar system known as the Kuiper Belt. And the Kuiper Belt is like the asteroid belt, but for comets. So the asteroid belt we've talked about in a previous episode when we talked about asteroids. Killer space rocks. It's an area between Mars and Jupiter that's filled with asteroids. Not like in Star Wars. The asteroids are millions of miles apart from each other. Okay. Drink for Star Wars.
Damn it!
It was a very obvious Star Wars.
I know, but I forgot about the rule.
All right. So you have basically these rocky objects in the asteroid belt that Jupiter's gravity prevented them from forming into an actual planet. All right, well, the Kuiper Belt is like that for comets, where you have billions of comets in orbit around the sun in this area, and within this area of billions of comets spread out by millions of miles between them. They're not all just like, hey, hanging out next to each other. You have objects that are large enough to be spherical, orbiting the sun. And so astronomers at that point were basically like, okay, is this a planet, or do we need to reclassify or distinguish what a planet actually is? Because again, the definition of a planet was spherical object orbiting the sun. That was as far as the technology had allowed their knowledge to go. But the technology had gotten good enough where the knowledge can now expand farther, and we can reclassify things based on new discoveries.
Right.
Based on New Horizons.
New Horizons.
Nice.
Which is the whole point of science. I mean, science is not about sticking with a predetermined model. It's not about sticking with what you were raised with. It's the whole point of science is to learn and evolve and adjust those preconceived notions on new data that comes in.
Right. So as we learn more, we change our definition.
We change our definition.
And that's how science works.
Yeah, science is ever evolving because we're going to get new data. We're going to get new information that allows us to expand and grow our knowledge.
But I just want to be sure for all the listeners, there's only one data.
There's
And
only
that's-
one
and
data. It's Brent Spiner in Next Generation, and now in
Yeah.
Picard on January
26th?
23rd, 26th, somewhere around there, 2020.
January 23rd.
I'm so excited. Anyway, so basically, Eris's discovery in 2005 triggered this whole debate on what a planet is. And so the International Astronomical Union, this is a group that basically is convened to name things and categorize things within our solar system. Right? Sure.
Let's go for it.
Okay, so we have some new rules. With what a planet is in our solar system. Now, this only applies to our solar system.
Key phrase.
In our solar system. Okay, this does not apply to other planetary systems we've discovered outside of our solar system. So exoplanets, that is TBD, to be determined on everything, which makes everything more confusing. But within our own solar system, the new rules for a planet are: a planet has to be spherical. Okay, we knew that. It has to orbit the sun. Great. Also, we knew that.
Makes sense.
Makes sense. Spherical and orbit the sun. Cool. Boom. Pluto's got those. The third rule fucks it all up. The third rule says that a planet has to have cleared its orbit. That means it must essentially be the dominant gravitational force to sweep out all other objects in its orbit. Yes, Brandon.
Well,
you want to say something.
I do, but we'll dive into this in a moment.
Okay.
You finish your point.
Okay, so Pluto did not clear its orbit.
Yeah.
Pluto is surrounded by billions of other objects in its orbit, not orbit.
Or share its orbit.
Share its orbit with billions of other objects. So not only Eris, but since Eris, we have discovered other what will be called dwarf planets, similar in size and shape to Pluto, but then also billions of comets.
Right.
So these, irregularly shaped icy bodies in orbit around our sun. So that third rule then throws a kink into everything, and so astronomers, the IAU, then has to come up with a new term for these objects that aren't comets, aren't asteroids, but also then aren't planets. They haven't cleared their orbits, and that term is dwarf planet.
Which has planet in it.
Which makes it even more confusing. Thanks, IAU.
Right.
So it's not a planet. It's like an almost planet. It's like a planet that could if it swept out its orbit.
The little planet that could.
The little planets that could, which are Pluto, Eris, Ceres is one in the asteroid belt. In fact, Ceres was originally thought of as a planet, and then it was changed to a dwarf planet, and now it is then it was changed to an asteroid, and now it is a dwarf planet. So Ceres was demoted and then promoted. Promoted. This is when the alcohol comes into play.
Oh, there's so much alcohol.
And then there's several other dwarf planets that are hanging out in the Kuiper Belt with Pluto, such as there's shit, I don't remember. There's one with a really weird name. It's like Quirl.
Yeah.
Oh, yeah.
The Q1.
Q1. Yeah, it's supposed to be QU something, and there's like a Mea or something, and Make.
So it's Hamea and Make.
Hamea, Make.
Because Make is the Hawaiian god of fertility, and that's what name I tried it by after.
There you go.
Nice. Nice.
Is that in hopes of something?
But no, it just felt like I like the general idea of having a fertility god in the house. It amuses me.
I like it.
Well, my issue with I have to clarify this. I have no problem with Pluto being a dwarf planet.
Okay.
Because That's what it is. We're finding all these objects that's similar to it. We need to change our definitions.
We have like 15 planets in the solar system. I mean, Jesus.
Right. I know, right? My issue is that with that third bullet point, that it has the clearest orbit, that there is no way to quantify that.
Which is what I love Liz said as the dominant gravitational force in its orbit.
Yeah.
Like the Earth hasn't cleared its orbit out. Jupiter still has its Trojans and such.
But it's the dominant force.
But from a science point of view, how do you quantify that? You need to quantify that. Because
Earth has the moon and maybe a couple asteroids in its orbit. Jupiter has a few hundred asteroids in its orbit, whereas Pluto shares its orbit with the billions of other objects.
Right. So if you add up that mass of everything that shares the orbit of the Earth, it is insignificant compared to the mass of the Earth. If you do that for Jupiter, it is insignificant compared to Jupiter. If you do it for Pluto, it is like 2 times greater than Pluto.
Yeah, so Pluto is not the dominant force.
That's a good point.
Especially because Eris is about the same size as Pluto. Initially, it was thought to be bigger than Pluto, and that is when people were like, "Whoa, hold the phones, we got something bigger than Pluto."
But let's say for example, let's say you stuck Mercury out where Pluto is. Would Mercury, for example, be considered a planet? I don't know the exact mass of those Kuiper objects in the orbit around Pluto. But would that still be greater?
Most likely not.
No.
I mean, because one of the arguments that I hear is that if you put Earth out at the orbit of Pluto, then it's not going to clear its orbit and all that kind of stuff. And that's fine.
Couldn't it have cleared it when the solar system was forming? I mean, these things are well established now after 4.5 million years. I mean, when the solar system was forming, it's a little bit of a different.
I guess my only issue is that that there's no quantification. So if you say that a planet has to, if you take all the mass located in its orbital plane, its orbital area, and you need to define that, that mass is what? 0.1? The mass of the planet? 0.01? Where do you draw the line?
So it sounds as if I may reach back into my educational background, that this necessarily can't be defined by a quantitative aspect, but you have to look into society and our cultural definition and what we qualitatively call it as. And if we as society determine that this definition should be a dwarf planet based on qualitative reasoning, then that's what we're going to roll with it.
Right, but that's not what has happened, because if you societally look at it, they want to call it a planet.
Well, that's because most of society at this
have
point
we taken a vote?
Has grown up.
What's the vote? What's the voting age
so,
of planethood definitions? Is it 18? Is it 16?
18,
because that's going to skew the demographics.
So here's the thing. Okay, so
was Nate Silver? We need him right now.
Here's the problem with societal things is that most people grew up with Pluto being a planet, and so there's a nostalgia and there's this sentimental factor that then people want to keep it as a planet, and the whole it's a textbooks.
No, we used to have lead paint and it was fine. Nostalgia doesn't mean that.
Science does not care what you think.
No, science doesn't care what you think, and that's the point.
It does care though.
No, it doesn't.
Well, science itself, it's the scientists that care. But so here's the thing. Like, people, I had a point and I was gonna be spot on it, but now I've forgotten it because of this whole back and forth. But anyway, so society, of course, it's like every planetary show I did that I mentioned Pluto, there was always at least one person that was Pluto's a planet. But the thing is, though, Pluto is very much different than all the other planets in the solar system. Not only does it share its orbit with billions of other objects, its orbit is tilted, again, 5 degrees off the plane of our solar system. It develops a tail like a comet as it gets closer to the sun. So, really, it doesn't really fit in. It doesn't fit as a comet. And it doesn't fit as a planet. And so then you have this new classification of, okay, what about these objects that don't really fit perfectly in these buckets? what can we call them? And so I think that's where dwarf planets come into play.
Right.
Because I think it's important that you have these classifications instead of lumping things into a category just because of, well, it's spherical and orbits the sun, so might as well be a planet. Because the more classifications you have, the better you are to understand these different types of objects.
Right.
And
those classifications change as more objects
and as you learn
are
more.
discovered.
Yeah,
absolutely.
As you learn more and define. So, could Pluto stay a dwarf planet? Maybe, maybe not. It depends on what future science is going to tell us.
And then another thing to look at as well is Neptune's largest moon, Triton. Triton is about the same size, volume, mass as Pluto, same composition as well, but it's a moon. And it's actually a captured moon, so it was probably at one point like Pluto.
It was probably a Kuiper Belt object.
Yeah, but we know it was captured because all the moons, let's say, go clockwise around Neptune, but Triton here goes counterclockwise. So it wasn't made in the same fashion. It was captured. So it was very much so the same thing as Pluto at one point. So would you think if Earth was around Jupiter, I would still call that a moon. So I guess it's lots of contextual evidence to go through as well.
I mean, I think moons, though, have a very strict definition, being a satellite of another body. So whereas, our moon and Triton, Triton distinctly orbits Neptune, whereas Pluto, of course, orbits the sun. But Triton could have been in the Kuiper Belt orbiting the sun at one point and been captured by Neptune, depending on its orbit and whatever factors happened, and now it is a moon of Neptune.
It's a really cool moon, though, to be fair.
It is a really cool moon. It's got nitrogen geysers that blow
at a
90-degree angle, which is really weird, and astronomers haven't figured out why these geysers...
It goes straight up first, and then it cuts out to 90 degrees.
Literally 90-degree angle.
And then it bends at a 90-degree angle,
and that's super cool.
What the fuck is happening there? I mean, it's amazing. There is so much to our own solar system that we don't understand, that we have yet to explore.
Let's do it.
And we're really, and one of my favorite quotes of a planetarium show that I saw was an exoplanet show, and it was narrated by the actor who played Odo in Deep Space Nine. And he says that we're basically in the horse and buggy days of space exploration. Mm-hmm. And I love that because it's really so true. We're really true. In our infancy of space exploration. I mean, we just had a spacecraft leave the solar system, so to speak, the influence of our sun. Mm-hmm. And so there's a lot we don't understand. And so in this process, in this infancy, so to speak, we're just starting to define things and explain the things we're observing. And I think it's really important to have that distinction and those definitions and classification of asteroids, comets, planets, dwarf planets, star, moon, all that, because the more we refine things, then the better we can then understand and explain things, then the more data we can get.
And I think a real world example of that, because it's just what it reminded me of, in the 1700s, early 1800s, astronomers were looking for an aether in space. Mm-hmm. And you'd be able to judge this aether by the motion of the planets, the motions of the stars out there. And then we're moving on, discovering that the aether doesn't exist. But now we have this weird dark matter where we know something should be there. We just can't find it. So it's an interesting progression of just like you're talking about.
Right. Yeah. And ether, by the way, in the early 1900s, they still thought the ether existed. I
love that.
The Michelson-Morley experiment, which, the Michelson-Morley experiment is an experiment that disproved the ether.
Oh, love it. And if I can take this full circle here, in the early 1900s as well, people thought you don't study physics because we just have to study every physics, and then Einstein blew it up. So with Clyde Tombaugh, when he was doing the observations, a lot of the people around him, a lot of those astronomers thought, you're wasting your time. We pretty much have it all tied up neatly. And, of course, that blows up as well.
Right. And to be honest, for anybody that's listening, when you have a scientist says that, we're pretty much at the end, they're full of fucking shit.
Yeah, no, there's no end.
No.
This is not...
No. Prior to Einstein, it was physicists are going to become biologists where they're just naming things. And then quantum happened, 1905.
Mm-hmm.
Well, Einstein, but quantum was actually a few years prior to that. But a little letter H changed everything in physics.
For the constant, Hubble's constant?
Not Hubble's constant. That's a big letter H.
Oh, okay.
This is Planck's constant.
Oh, okay.
And if it had been like 0, yes, we would probably be a biologist at this point, naming things and classifying things. But it was non-zero. It was very small, but non-zero.
And the fact that the definition of a planet that we have today, according to the International Astronomical Union, the IAU, the fact that it only applies to our solar system is, we have discovered so many other planetary systems out there. So those are basically solar systems outside of our solar system. There's so much to discover that it's like, okay, I am on the team Pluto, not a planet, just because that I like the different classification of things. And for me, Pluto, it's not like the other planets. It is different. It has different attributes. It has different behaviors than the other planets that we know of in our own solar system. And so I think that's important to define and to single out those differences, because there actually was a debate recently in April this year between Alan Stern. So Alan Stern, he's a planetary scientist. He was the principal investigator on the New Horizons mission. He is very much so in the Pluto as a planet camp. Very much so.
He's the general of the camp.
He is the general of the camp. And he debated against somebody else who's not in that camp, who's on the Pluto's Dwarf Planet camp, not a planet camp. I can't remember the name because I didn't write it down in my notes.
Was it Mike Brown?
No, it wasn't Mike Brown. It was somebody else.
I would watch that if it was Mike Brown.
Oh,
yeah.
Pay-per-view, I would.
So
absolutely.
Mike Brown is, of course, the Pluto's not a planet camp.
He's the original planet killer.
He's the original planet killer.
He literally wrote the book about planet killing.
And so they actually held a debate in April about Pluto's classification, and the opponents of Pluto being a dwarf planet, Pluto being a planet, is that the definition should be based on geophysical attributes, not necessarily spatial, like where it is, your distance from your sun attributes.
Context matters, folks.
Yeah, so basically a planet is a substellar object that has never undergone nuclear fusion and is rounded by its own gravity, regardless of its orbital parameters. So that's basically
Pre-2006 definition.
That is basically a planet is spherical and orbits the sun and doesn't have nuclear fusion, because obviously if you have nuclear fusion, you're a star. Yeah. So, and so I just think that's too narrow. That's not broad enough. That's not, because there's just of what we've seen with the Kuiper belt. There are so many other objects out there that don't fit in this, that just, and if we had Alan Stern's definition of a planet, where it's just a spherical object orbiting the sun, basically, that doesn't do nuclear fusion, how many planets would we have in our solar system?
More
Hundreds.
I mean, there'd be a ton. I mean, you can't put that into a nice acronym that elementary kids learn. My mother.
My very.
I don't. You don't even know it. You don't even know it.
I don't remember it. I don't. Something about making pizzas.
My very eager mother just.
Yeah, that's right.
Made nachos.
My very eager mother just
served.
Nachos.
Let's go with that.
Just go with that stuff.
I don't remember what the rest of it is.
Okay.
Stop. There's no P. That's it. There's no P.
Well, the P was pizza. It used to be pizza.
Ain't no P in there.
But there's no P now.
Damn. No P for you.
Well, the crazy thing in this is, so we mentioned Mike Brown. Look him up. the original planet killer, Pluto killer. Wait, what's he go by? Is it Planet Killer? It goes Planet Killer.
I don't know, but we were gonna have a drink called Planet Killer.
Right. So if you in Twitter, I think it's Planet Killer. But anyway, so he actually, the very guy that got rid of Pluto as the ninth planet in the solar system, thinks there might be a Planet X.
Another Planet X.
Right, this Neptune-sized object out there. How is that going to change the definition? This is a hypothetical question.
If you have, well, it's not going to, because at that distance from the sun, there's no way anything's going to clear its orbit. But if you're a Neptune-sized object with Neptune-sized mass, what would you call that? Extrasolar planet?
Well, and is it that far out?
Because that implies exoplanet.
Because
that'd be a rogue planet.
Well, and if that at that mass, at that distance, I should say, can it be gaseous like Neptune or?
Yeah. Talking about ice giants, yeah.
Yeah, ice giant. Well, I think if they discover it, we then go back, and as science does, we reevaluate, and we come up with a more modern definition of a planet. But it needs to be something that you can quantify.
Right.
Because that's how science works.
Right. Well, and I think that's an important part of science, is that evolution and that quantification based on new data. You know, because if we just said, oh, okay, here's Eris, here's an object that orbits the sun in the Kuiper Belt, where Pluto is also orbiting, and, you know, it's about the same size as Pluto, you know, and if there's no extra thought to that, if there's no, okay, it's a planet, then science isn't sciencing. People aren't doing science justice, you know, to really think about, okay, here is something that doesn't fit within the normal parameters of what we know a planet can be or is based on what we've observed. Because if you look at Mercury through Neptune, because Uranus is before Neptune, through Neptune, I mean, these objects are, you know, they don't really have much in their way. It's just them and a couple other objects hanging out with them in their orbits. They're orbiting the sun, doing their thing, you know. But then when you look past that, you go, oh shit, you know, we got Pluto, but Pluto's not alone. Pluto's got several other objects that are very similar to it, but then it's also got what we know as comets in its same orbit. You know, so you do have to take a step back and then reevaluate. Well, then what are these? And I think that's very important, instead of just going, oh, it's a planet. You know, and just, oh, sure, it's this.
I think that sums everything up very nicely.
Thank you, Brandon.
You're welcome.
So, I'm clearly on the Pluto's not a planet, it's a dwarf planet. For now, depending on what the science shows, on what future observations show.
Right, and in all honesty, I'm on that same team, and I can't see... The only thing that might throw a monkey wrench in this would be Mike Brown's planet.
Well, Planet X. Yeah, because
I think, because I think one of the most exciting things in science is to be proven wrong. Because that opens up the door for a whole different world of exploration.
That is, and
it's new physics.
I love that debate. So when you have, and this is going totally off topic, but when you have, you know, creationists, so to speak, that are like, well, blah, and then you have, you know, evolutionary biologists. It's like, great, show me the evidence. Evolutionary biologists are like, if you have the evidence, prove me wrong. That'll be a Nobel Prize in biology. Like, that would be amazing.
Right.
You know, because scientists are always open to new information and new data, even if it is something that they're, oh, yes, I'm so aligned with this worldview and it fits and I like it. But if new data comes in, then they're open to that new data because it means that they've learned more. That's more information to help define the world and universe that we live in. And I think that's so important, to being locked in some
Right.
strict mindset based on nothing.
Because science finds a way.
Science finds a way.
Science finds a way.
It evolves. It is alive, so to speak, based on how our technology develops and where we can go with it, you know?
Just reminds me of the hills are alive with science.
The hills are alive with the sound of science.
Yeah, and as a person, individual, we should all be, for me personally, and I should strive for this, is to be open to what the science tells us.
Yeah, I mean, if you have the evidence, if you have the data,
Yep.
all right.
Yep. And
if
I
you
think
have the proof.
and I think at this point we're kind of repeating ourselves a lot.
I know, we've gone into a loop of, hey.
Science is cool, it corrects itself, and it's wrong a lot of the times. So I guess we should kind of close it up with beyond what you've said, Liz. Any quick closing thoughts? We'll go with the mic next.
I think closing thoughts is that the science has and the discoveries have shown us that Pluto is different from what our preconceived notions of a planet should be, and I think that should be accepted, and that we should look for more evidence on what's out there and not be constrained to just our solar system, because we're discovering a lot of planetary systems out there and we're just beginning. So we have a lot to learn.
Right, and yeah, like I said, Pluto really is the story of science. Mm-hmm. And as we learn more, our ideas about the universe should change to reflect those ideas. Mm-hmm. Now, I completely get that if you were 5 years old and Pluto was a planet, that, hey, it's always a planet, I love it, it's always a planet, it's going to be a planet forever, but that's not how science works. And so, I mean, really and truly, Pluto just epitomizes the story of science.
It's a perfect depiction of how science works.
Yeah, and
that evolution and change.
And
more information.
All because we don't call it a classical planet anymore. We call it a dwarf planet. Doesn't mean you can't love it.
I know, it's still there. It's not like it doesn't exist.
Right.
It's still Pluto.
And you know what? With New Horizons and the data we got,
it's amazing.
You can love it even more.
It's an amazing, beautiful world full of contrasts and activity.
Brandon, your thoughts?
I concur.
That's why we're friends.
No, it's definitely for me going back to that Percival Lowe quote we had, just using your imagination and basing it off facts to expand your horizons. Mm-hmm. I think that's a beautiful idea, and science does a wonderful job of that, trying to find out what's true out there and how you are wrong. And a lot of times that takes so much imagination to imagine what other existences may be out there to change your line of thinking. And I like it.
I like it.
All right.
Mm-hmm. Yeah. And that's
our
Pluto.
Our look at Pluto. So, what are we talking about in a few weeks?
We're talking about it's Halloween. It's getting close to Halloween. So we're going to be talking about what? Monsters of the Galaxy?
Monsters of the Galaxy.
Oh yeah, some creepy shit out there in the universe.
The exoplanets that will scare you.
Yeah. So if you
Pulsar, wait. Pulsars that start your heart racing because the moves fast.
Huh. But you think you know what a planet is? You think you're safe with your rocky world and your gas giants?
Y'all don't know shit.
You don't know what's fucking going on out there. So we got a horror show of the universe for you.
Right, and Liz and I had a conversation about vampires yesterday.
Wait, y'all talked without me?
We did.
Yeah, we did.
We are going to bring that in.
We talk a lot without you. Because we live together.
I am appalled.
But we had an amazing conversation at a theme park yesterday about what kind of light affects a vampire. So we're gonna bring
Oh, damn.
that in.
We're
to
bringing
the
that
next,
in a
We'll
few
bring that
weeks.
into the next podcast.
Well, okay, yeah. Hold
We'll
on.
get there.
I have thoughts.
Okay.
All right.
Well, we have thoughts too. So
Not now.
we'll talk about
a few
that
weeks.
because
We
current
can
definition of vampire is very strict.
We can stretch a show up another 2 hours, right?
No, it's already gone
All right.
too long. I
Well,
got a lot to edit.
This was fantastic.
It was fantastic. Thank you for those listening. You can follow us at Drinking Cosmos on Twitter. Follow us there. You can hit up our website at cosmoswithcosmos.com. And currently we're streaming on Twitch.
Which I think we'll do regularly.
Under
now.
my username currently, which is Skizdiz. It's an inside joke from long ago. But we'll probably make our new Cosmos with Cosmos Twitch and YouTube as well. So thanks.
So we'll see you next time. Thank you.
For joining, and thanks, and we'll
Bye, everybody.
see you. Live long.
Live long and prosper.